all would have heard this term at least once in your life. Such is the kind of buzz that artificial intelligence or AI has created. Almost everything in today's world uses AI in some way or the other, be it your daily Netflix recommendations or predicting the stock market prices. With more and more data being generated each day, the need for technologies like AI is now more than ever. So, what really is artificial intelligence? AI is the science of simulating human behavior in machines that are programmed to perform tasks like humans and mimic their actions. Any machine that exhibits human like traits such as problem solving and learning constitutes AI. Ever wondered about how a Tesla drives by itself from one place to another without the intervention of any humans? This is possible due to AI. You would be surprised to know how that AI is not a new technology. It all started with the simple question, can machines think, which was asked by mathematician Alan Turing in the year 1950. A side note, Alan Turing was the man behind decoding the Nazi encryption machine called Enigma, which led to the victory of Allied forces in the World War II. The term artificial intelligence was first coined in the year 1955 by John McCarthy from Dartmouth College, Nathaniel Rochester from IBM, Marvin Minsky from Harvard University, and Claude Shannon from Bell Telephone Laboratories. The first artificial intelligence program, The Logical Theorist, was presented by Alan Newell, Herbert Simon, and Cliff Shaw at the Dartmouth Conference in the year 1956. The program was designed to mimic humans' problem solving skills and went on to prove 38 of the 52 theorems of Principia Mathematica by Whitehead and Russell. From imitating mere problem solving skills to currently building driverless cars, we can see the significant improvement of AI over the years. Now, how does AI work? The main principle of AI is feeding input data, processing it, analyzing it for any patterns or correlations, and then using these patterns to make predictions or future decisions. Therefore, it emphasizes on three human like behaviors: learning, reasoning, and realizing. Learning. In this stage, the main focus is to acquire data and make rules or algorithms as to how we can turn that data into something useful. After defining a certain number of algorithms in this learning stage, we now have to choose which is the best one for the task. This is done in the reasoning stage. In the realizing stage, the algorithms are trained over and over again with the right data to ensure that they provide accurate predictions and make important decisions. With that, now we will look into four major subdomains of AI, namely machine learning, deep learning, natural language processing, and robotics. We will now be discussing these in detail. Firstly, let us look at machine learning. Machine learning or ML is the idea or the science of computer programs that can automatically learn from their previous experiences and adapt to the new challenges without any human intervention. It is one of the most used and demanding fields of AI, and that is the reason we'll be discussing it more in detail. The machine learning algorithms are coded in certain order to perform tasks, analyze, and predict information from the given data. And depending on the type of data that is available and what they want to be predicted out of the data, ML algorithms can be divided into three types. Supervised learning. Supervised learning algorithms are the most commonly used type of algorithms. You may ask why. It is due to the fact that they're simple and easy to implement. The input is in the form of label example pairs, which are usually in a text, spreadsheet, or a CSV file. These label example pairs are fed one by one to the learning algorithm, allowing it to predict the right label for each example. The algorithms are focused on one single task or a problem. An example of a label example pair is as shown below. Here you can see that the employee name, employee ID, gender, position, department, and employee satisfaction are all attributes of one dataset. Moving on to the next one, unsupervised learning. We can say that supervised and unsupervised learning are two extreme ends. Here we do not give a specific target for the model, nor do we give it a feedback. Instead, the machine only has to find a way to learn by itself. Input data is usually in the form of unlabeled data and unstructured data, which is basically data that contains missing values or unknown data. Examples of unstructured data include text files, flat files, system logs, etc. Moving on to the next one, we have reinforcement learning. The models in reinforcement learning are trained to make not one, but a sequence of decisions in an interactive or a complex environment by using the feedback from its own previous experiences and decisions. Here, the models use trial and error methods. An example of this would be self driving cars. The input data here consists of data from a wide variety of sensors on the car. If you guys want to know more about machine learning, there is a dedicated video for that, for which I'll be providing the link in the description box down below. Moving on to the second subdomain of AI, deep learning. Explaining this will be easier now as we already know what machine learning is. We can say that it is a type of AI that teaches a computer to behave exactly like that of the human brain. From the learning stages to predicting and classifying information, a deep learning network processes and analyzes data like how a normal human brain would process it. This is done with the help of neural networks. Neural networks are a set of algorithms that are modeled after the human brain, with recognizing patterns as the main motive. Structure of a neural network consists of a number of nodes which are loosely designed to compute like that of a neuron in the human brain. Typically, neurons are arranged in a series of layers. The input layer, which receives various forms of data from the outside world. The hidden layer, this is where the computations happen. This layer consists of many units and its main job is to convert the input data into something that can be used by the third layer, which is the output layer. An analogy of deep learning would be that of a child who is learning a new language. The next subdomain of AI is natural language processing, or NLP as it commonly called. NLP deals with communication between humans and machines by natural language. The technique involves processing of human languages and it enables the computers to read and understand data, mainly by imitating human natural language. In layman words, NLP algorithms try to break down the language into shorter, simple pieces, understand the correlations between those pieces, and determine how the pieces can be put together to create meaning. NLP is important as it makes it possible for computers to hear speech, read text, interpret it, and determine which parts of the text or speech are useful. Some of the applications of NLP include speech recognition, Twitter's sentiment analysis, which is used to filter hate language from various tweets, and spam detection. Lastly, we'll move on to robotics. As the name suggests, robotics involve the programming and designing of robots. Robots are often deployed to perform tasks which are laborious and difficult for humans to perform. Robotics is probably the only field where software, electronics, and mechanics are brought together. It has computer programs that tell the robot what, when, and how to perform a particular task. It consists of mechanical components for performing that task, and it has electrical elements for providing power and controlling the machinery. Some of the main applications of robotics are manufacturing, military applications, outer space applications, and health service. With the number of applications of AI increasing each day, people might only think of one question: will AI eat up jobs in the future? Not all the applications of AI are the same as factory automation or robotics. Industry sectors which involve manufacturing goods and products thrive on efficiency and low cost. They would save so much investing on AI when compared to investing in human labor. In fact, some factories in the world have already made their complete process automatic, and there are more factories which will follow the same feat in the future. But there is no need to panic because reports from various giant firms state that AI will create a plethora of new jobs. Experts also think that if anything AI will do in the future, it will be creating new jobs. The jobs we don't even know that they existed in the first place. In fact, PwC predicts that over the next 20 years, AI will create around 7.2 million jobs in the UK alone. That being said, yes, it will displace some jobs, but not all the jobs in the world. I hope this gave you some clear cut insights on what AI is, how it works, and the subdomains of AI. Please do subscribe to not miss out on more such content. Keep learning, and goodbye. Have you guys ever wanted to build your dream career in artificial intelligence? Well, you are in luck because today we'll be talking about how one can land that dream job in AI. We will be discussing the skills required to start a career in AI and also the average salary trends in the field of AI. But let us first understand what AI is in a simple manner. AI is the science of imitating human behavior in computers or machines that are programmed to function and perform tasks like us humans. Any machine that exhibits or mimics human-like traits constitute AI. These days, AI is used almost everywhere, and due to this, there is a huge demand for people working in the field of AI. Let us move on to the skills required to really start a career in AI. Typically, a bachelor's degree in computer science is required, but like every other job role, if you want to excel in AI, your fundamentals needs to be strong. Firstly, basic skills like maths, which include linear algebra, statistics, and integral calculus are important. In AI, the need for maths and statistics is crucial as almost all the jobs in AI require problem solving skills. AI requires a person to be good in statistical thinking and logical reasoning. In fact, the most preferred qualification after computer science knowledge or a CS degree is statistics. Having a grip over maths and statistics helps you understand most of the machine learning algorithms as they revolve around linear algebra and probability distributions. Coming to the next important basic skill, computer science knowledge. Like we discussed earlier, a degree in computer science is required but not mandatory. Having said this, knowledge in computer science, mainly in programming languages like Python, R, and programming concepts like databases, data structures, and algorithms will take you a long way in the field of AI and almost always gives you a competitive edge over others. Apart from these, having to show that one has a clear understanding of data sources like Kaggle, data mining, and web scraping are also an added advantage. If you don't know what web scraping is, it is simply taking data from various websites and converting it into structured data, which makes it easy to analyze or derive insights out of. Now that you've learned the Python programming language, you can now explore Python libraries used for machine learning. For examples, two such commonly used libraries are NumPy, which is used for math operations on multidimensional arrays, and Pandas, which is used for data analysis or importing data from various file formats. In addition to machine learning libraries, a knowledge of machine learning algorithms can take you a long way as well. Some of the commonly used algorithms are decision trees, which is a diagram or a chart that defines a specific course of action or an outcome, and linear regressions. This is used to find out the relationship between variables and predicting certain values. Since it is linear regression, the relationship is between two variables. Another best way to showcase your practical knowledge in these concepts is to try and create a few projects on the same. This definitely will help you get recognized in a pool of ordinary applicants who do not have any projects. After having a go at basic machine learning algorithms, one can start widening their skill set by exploring another branch of AI, which is deep learning. Deep learning is a branch of AI that deals with processing and analyzing data like how a normal human brain would do it. Here, the concepts of neural networks come into picture. Neural networks are similar to that of a human brain. Each neural network has a collection of nodes which perform the functions like that of a neuron in a human brain. Depending on the purpose you want to serve, there are different types of neural networks. Three types of neural networks are artificial neural networks. An example of this is stock price prediction, convolutional neural network, which is used for image processing, and recurrent neural networks. This is used for voice search applications like Google's voice assistant and Amazon's Alexa. Apart from these technical skills, non-technical skills such as critical thinking, curious nature, creativity, and ability to stay up to date with the new technologies goes hand in hand with almost every job in AI. It requires you to not just arrive at a decision, but wants you to arrive at it using trial and error and mandatory testing. If you want to excel in AI, one must be curious and creative. Having to ask the right questions at the right time and always wanting to learn more are two key aspects that a person wanting to land a job in AI must focus on. AI aspirants must have a passion for staying up to date with every new technological development there is. Main motive behind this is to be familiar with all that is going on in the tech industry and try to come up with innovations. Now we'll look at the salary trends for some of the common jobs in AI. Firstly, there is artificial intelligence engineer. According to Glassdoor, the national average salary of an AI engineer in India is around 8,51,755 rupees, and in the US it is about 118,416 US dollars. Big data engineer. You can pursue this career if you have a liking for distributed computing. The average salary in India is around 7,49,718 rupees, and whereas this sum in the US is about 151,307 US dollars. An average machine learning engineer in India earns about 7,60,000 rupees per annum, and in the US, the average salary is around 147,855 US dollars. A data scientist is one of the most searched roles, and it can fetch you close to 9 lakhs per annum in India and around $119,414 in the US. On an average, a deep learning engineer in India earns about 8 lakhs per annum, and the same job role will fetch you about $136,307 in the US. To conclude, always keep in mind that the more you learn, the higher the chance there is to grow professionally. And especially since AI being a vast technology, it is paving way to new and trendy innovations, and thus one has to keep up with the moving trends.
Hi everyone, welcome to another video by Scalar where we are going to discuss and differentiate between artificial intelligence and machine learning. Today's discussion is going to be very interesting as we will discuss the career path of both areas and how they are different and how you can excel in any career regardless of which one you pick. When building a career in data science, it must get really intimidating to judge which road will assure you success. Are you a person having thoughts like what is the difference between AI and ML? Or simply someone thinking about which career option to go for and how to pursue a particular path? Don't worry, we are here to guide you through it all. In this particular session, we will first learn about AI and how it is different from ML, the different roadmaps we need to follow and the scope in the both fields. We will also cover salary and job outlooks for the two. We acknowledge that making a career choice is a lifetime decision, and thus we try to impart most knowledge from this video that we can. But before we get started, please take some time out and subscribe to our channel. Also press the bell icon so you never miss an update from our end. So without wasting more time, let's get right into it. Curious what makes machine learning different from AI? In this digital era of self-driving cars and intelligent robots, AI and ML have created more hypes than ever. They are continuously empowering new technologies to improve systems like medical diagnosis and other important areas. But what is making the two different? In simple words, machine learning is a small part of AI. So machine learning can be AI, but not all AI can be machine learning. AI is the biggest, all-inclusive factor containing a smaller subset like machine learning, deep learning and neural networks. AI provides the machine feature that mimics human intelligence. On the other hand, machine learning practically implements human-like information processes. So one can say that without ML, AI can be a tricky pony even when performing a single superhuman task. Want an interesting example of AI? Do you remember how AI showed the power of technology only by defeating champions at games like chess in the early days? Today, after multiple advancements, AI can now employ face, speech and picture recognition, including translation. In fact, nowadays, AI has incorporated more human-like components like Alexa and Siri to connect to human emotion and interpret tones. However, when talking about machine learning, it is how Alexa and Siri can acquire their diverse functionalities. With the help of machine learning, AI can perform more than a single task to interpret data into patterns and make predictions like recommendation in song apps, as well as movies and videos on Netflix and YouTube. Now let's get into more details about AI and ML. What is artificial intelligence? Artificial intelligence is a comprehensive phrase that describes the process and software that impersonates human intelligence. It covers a vast range of studies including computer vision, machine learning, natural language processing, autonomous system and robotics. With the use of AI, machine can identify patterns, solve problems and provide insights to businesses and humans. According to top evangelists, it is quite difficult to overstate the impact and reach of AI in the next decade. It is a dynamic field that can be directly compared to the rate of transformation of electricity from the late 1800s till now. Remember, AI's impact will be even greater than the world has ever seen. Artificial intelligence covers the computational aspect of the term. Also, since we do not define machine reasoning outside the concept of human behavior and thinking, we can say AI and human intelligence are directly linked. Now let's talk about what is machine learning. Machine learning, on the other hand, is a part of AI. In other words, where AI is overall the definition of being smart, ML is from where a machine is extracting data, learning about things that would be difficult for a human. Machine learning has the capability to go beyond human intelligence. It is primarily used for big data in a short period using algorithms to be a better process. For example, a manufacturing plant collects information from the machine and sensors present on its network in unit to go far beyond human normally can process. The system then accesses patterns and identifies anomalies that indicates the problem human can address. Here are a few points to help you differentiate between AI and machine learning in terms of skills required. Now that you know that both are two different concepts, you must work on your skill sets as required by the given field for a brighter career. Are you eager to know the skills that you can add to your resume? Because AI is a term that encompasses various aspects of smart technologies, the skill set required is more theoretical than technical. On the contrary, aspiring candidates looking forward to machine learning as their career must have a high level of technical expertise. Skills required for AI. Students pursuing career in AI must have a strong hold on data science, algorithm and techniques for proper analysis, robotics, machine learning and how to draw conclusion, Java programming, data mining, programming design, problem solving, ethical standards in developing AI system. Skills required in machine learning. Students pursuing machine learning must have a strong hold in physics, neural network architectures, applied mathematics, natural language processing, algorithms, data modeling and evaluation, probability and statistics, data modeling and evaluation. When discussing career paths, the decision becomes even clearer when you know the job role you have to play in the field. If you want to know about the responsibilities you will be interested with, stay with us. We are going to state some career opportunities you can opt in artificial intelligence field. AI job opportunities have been on an upswing for the past decade. If you think you have a driven mind and are fond of transforming and improving the existing system, you are the best fit for an AI job. The good news is that as the world is advancing, the scope for AI related job is increasing more than ever. However, to understand whether you want to proceed in this career path or not, let us discuss some job roles, shall we? AI developer. The key responsibility of AI developer are to carry statistical analysis, test, design and develop machine learning programs. In addition, the professional is also entrusted with implementing a well-performing algorithm, deep learning system and training ML system containing a perfect data set. Programming skills required for this are Python, Java and Scala. Frameworks required are scikit-learn, Apache Hadoop, Azure, Spark MLib, Amazon Machine Learning, Apache Signa, H2O, ML Studio. Next up, data scientist. A data scientist finds valuable data sources and streams to work with data engineers to automate data collection processes. In addition, they carry huge data analysis to recognize patterns and trends to build predictive models and stats. This in turn helps the company to propose a solution, build a strategy, and create a comprehensive ML system using visualization techniques and tools. Programming skills required are R, Scala, SQL, Python, SSAS, SAS. Framework required are Apache Hadoop, Azure, Spark MLib. Next role we have is data science lead. The job role of data science team lead is to provide direction and manage resources. The position of a data science lead requires high level of knowledge in the field of machine learning architectures, big data systems, data science technique, machine learning architectures, and interpersonal skills. It is task of analytical manager to set priorities for analytics and data science team to elaborate on finding of the senior management. Programming tools required are Tableau, SQL, Excel, Python, R, and Power BI. Soft skills required are strong management and interpersonal skills. Next up, we have research scientist. Suppose you are looking for pursuing a career as a research scientist. In that case, you are expected to have mastery in multiple AI disciplines like computational statistics, mathematics, deep learning, and machine learning. Similar to the case of data scientist, a research scientist too is expected to hold an advanced or doctoral level of degree in computer science. Programming skills required are R, Python, Scala, SSAS, SAS. Frameworks required are Hadoop, Apache Signa, Azure, ML Studio. Career opportunities you can opt in machine learning field. Machine learning has been one of the most popular career paths since its boom recently. In fact, it was even ranked as the best job to have in the year 2019 according to some research. It is mainly because of the work significantly reduces human effort and improves the machine's performance by enabling them to learn things by themselves. The job roles you can choose for yourself including machine learning engineering, NPL scientist, business intelligence developer, data scientist, and human-centered machine learning designers. Let's begin with machine learning engineer. As the name suggests, the machine learning engineer is interested with running machines, learning experiments using programming skills like Java, Python, Scala, and others. Moreover, when recruiting, the company usually looks at how well the candidate is accustomed to the data modeling, programming, statistics, probability, system design, and machine learning. Machine learning professionals also have to analyze data to develop effective algorithms that run autonomously without or with minimum human intervention. Programming languages required are Python, Scala, Java, C++, and R. Skills required are data modeling, system designs, software architecture, data structures, ML algorithms. NPL scientists. Not many have heard of NPL scientists. You may not have too. So let us clear the concept to you. NPL stands for Natural Language Processing, which involves enabling the machine to understand human language. In other words, the machine will be able to talk to human in their own language. It is just how Alexa talks to you. So the primary job of NPL scientists is to create a machine that contains patterns of speech and can translate spoken words into different languages. Thus, this position requires syntax, grammar, and spelling fluency of at least one language apart from machine learning. As a result, it helps in imparting the same skill to the machine. Applications, Duolingo and Grammarly. Skills required are basic level ML skills, syntax, grammar, and spelling fluency in one or more languages. Next up, we have business intelligence developer. A business intelligence developer is entrusted with machine learning and data analytics to analyze, collect, and interpret large chunk of data. As a result, come up with actionable insights used to make business decisions by company executives. To be clear, they use data to make a business decision better. The company identifies a professional to be an efficient business intelligence developer when they hold knowledge of multidimensional and relational databases. Also, the candidates must be well versed in Python, SQL, Scala, Perl, etc. In addition, if you have knowledge of Power BI, that would be cherry on the top. Programming languages required are Python, Scala, SQL, Perl. Moving on to data scientist. Did you know that according to Harvard Business article, a data scientist is acknowledged as the sexiest job of the 21st century? A data scientist makes use of an advanced analytical tools inclusive of predictive modeling and machine learning. As a result, able to accommodate, analyze and interpret large chunk of data and build productive actionable insights. Further, businesses use it to make an important decision regarding operation. So apart from having a machine learning skills, a data scientist must also hold knowledge of statistical research techniques, data mining and other big platforms. Moreover, if you are trying for the job role, programming languages you need to know: Python, Perl, SQL, Scala, R, SAS. Framework required are Pig, Hive, Hadoop, Flume and Spark. Moving on to human-centered machine learning designer. The human-centered machine learning designer job involves working on machine learning algorithms centered around the human world. It is because of this job role you get the most appropriate movie suggestion on Netflix. This type of designer develops various softwares that can perform human-centered tasks based on patterns and processings. It allows the machine to know the user's preferences without the help of cumbersome program for every scenario. Programming skills required are ML concepts, algorithms, statistics and mathematics. Now that you are clear on the job role of both career paths, you must be clear about your decision. However, do not forget the job scope and salary structure aspect of the field. If interested, stay connected. Know how much salary you can expect from the field and their scope. AI engineering has the most lucrative job path you can find in the world. Fortunately, it has been growing at a great pace. In fact, the average entry-level salary you can expect to get in India is around 8 lakhs. Moreover, as you proceed to the higher levels, the salary can extend up to 50 lakhs. ML engineering jobs, on the other hand, does not stay behind. There are also abundant job opportunities available in this particular field. The average salary that you can expect in India amounts to 6 lakhs, whereas it can go up to even 70 lakhs per year. To sum it up, till now we have discussed different tasks artificial intelligence and machine learning aspects can deal with. We now know that machine learning is only a subset of AI which works on macro level. Next, we pointed out the skill sets every candidate should necessarily gain according to their field of interest. Additionally, we also learned about job profile and salary we can expect from two paths. Scalar has launched an exclusive data science program which was created based on insights from 100 data scientists working at 50 top tech companies. The program helps you tackle the toughest problems in data science and machine learning. Experience live classes from data scientists, mentorship from top industry experts, and work hands-on with 40 plus critical tech tools to solve for real-world business problems. Know more about the program by clicking on the link in the description below. We hope you find yourself with all the necessary details that you would need to make an important career choice with this video. If you found this video helpful, do not forget to like this video. Also motivate us to come up with more such videos for you by subscribing to our channel and sharing it with others.
Hello everyone. Today we are going to learn about the threats and opportunities that have arisen due to advancement in the field of artificial intelligence. Are you also fascinated by the possibilities that artificial intelligence brings into the field of technology? Do you think that artificial intelligence is the next best cure to every human problem? The cure of diseases, performing complex activities, security, safety, as well as defense against the natural phenomenon. Everything has its benefits and disadvantages. And it is very important to understand how much you are willing to give in order for a world controlled by artificial intelligence. However, there are several aspects of artificial intelligence that make it the most advanced technology that man has ever achieved. automated functioning of different tasks in the field of education and development, integration with other technologies to make them automatic and increase the efficiency, use in health industries to study different diseases and find possible cures. This can be done with the help of simulations run by artificial intelligence, revolutionizing the manufacturing process of many organizations and making them more efficient. In this video session, we will be learning about artificial intelligence and the roles it will play in our lives. We will also go through the effects on the job market. Subscribe to our YouTube channel and press the bell icon to never miss any updates. Now, without delaying this session any further, let us begin. What is artificial intelligence? Artificial intelligence is a new phase of technological development for human beings. It is collectively an endeavor of science and engineering that is being used to make intelligent automatic devices. These devices include intelligent computer programs and automatic devices that work together with many integrated systems. It has a connection to the comparable job of understanding human intellect through the use of computers. Additionally, AI is not limited to biologically observable techniques. With the world moving towards technological development and enhancement, artificial intelligence is the glue that has held everything together. Artificial intelligence is affecting our lives more and more and in unimaginable ways. The use of devices such as voice-controlled soundboxes, lights, and security systems are all a product of artificial intelligence. It has started to revolutionize our world from smartphones to automatically driven cars. The world is moving towards betterment and automation. But if there are merits of something, there are bound to be some demerits. But before we get to the threats posed by AI, let us learn more about the history of artificial intelligence. In the following session, we will see a brief history of AIs and what was its initial purpose. History of AI. Artificial intelligence was developed to provide machines the ability to carry out several tasks without any human intervention. Let us learn more about the history of AI. The term AI was coined in 1956 at Dartmouth College. John McCarthy and Marvin Minsky were known as the founders of AI. It faced a period of criticism during the period 1974 to 1980, which was known as Cold Winters. Learning is a subfield of machine learning that is included in AI. By utilizing artificial intelligence, systems are now capable of apprehending and achieving particular goals. The former refers to computers that learn on their own without the help of humans from previously collected data. Text, pictures, and audio may all be processed by the computer using machine learning. Artificial intelligence should be able to perform certain tasks such as evaluation, learning, automatic solving of problems, and monitoring. Artificial intelligence has been with us for a long time, and it has rooted itself in many modules of humankind. In the next session, we will see the different types of AIs. Types of artificial intelligence. Artificial intelligence is broadly classified into two categories, namely strong AI and weak AI. Let us understand the two types of AI in detail. Weak artificial intelligence, ANI, or artificial narrow intelligence, is AI that has been specifically programmed to do a single job. The majority of today's artificial intelligence is powered by ineffective AI. There's no better term for this form of AI than narrow. This category of AI allows several extremely strong applications like iPhone's Siri and Amazon's Alexa, as well as self-driving cars from Tesla. Strong artificial intelligence. In order to have a strong artificial intelligence, you need both AGI and super intelligence. It's a speculative kind of artificial intelligence in which a computer would have intellect equivalent to those of mankind, with a conscience and awareness that can resolve issues, understand, and make goals and aspirations. Superintelligence or artificial superintelligence, ASI, might be superior to human brains and abilities. Despite the fact that strong AI is only a theory at this point, with no real-world applications, it doesn't imply that scientists today are not even working to advance it. What are machine learning and deep learning? Deep learning is a branch of machine learning, while machine learning is a subcategory of artificial intelligence. Artificial neural networks are the building blocks of deep learning. An artificial neural network with more than 3 tiers, including outputs and inputs, might be called a deep learning method. Machine learning and deep learning vary in that they employ different learning algorithms. Massive amounts of data repositories can be used with deep learning, since it automates extraction of features by requiring less human interaction. Deep learning may be thought of as customizable learning algorithms. Non-deep or traditional machine learning relies more on human input to learn. People with specialized knowledge decide on the future hierarchy needed to grasp the distinctions between different data sources. Annotated records, also known as supervised learning, can be used by deep machine learning to educate the algorithm. But this is not a requirement. Text, pictures, and many other unstructured and semi-structured information may all be consumed, and the software can automatically decide which attributes belong to which subcategories. Instead of requiring human interaction, machine learning uses data without our involvement, enabling us to expand that in more creative ways. With endless possibilities, AI is becoming the face of revolution in the technological industry. Therefore, let us learn in the following session its applications and the threats to its poses. Applications of artificial intelligence. There are several real-world applications that engineers have started to implement in our lives with the help of artificial intelligence. From AIs like Siri and Amazon's Alexa, AI is slowly crawling into our lives and we aren't aware of them. Therefore, let us see some of the applications of artificial intelligence. Speech recognition. There are several names for this technology, including speech-to-text, automated speech recognition ASR, computer voice recognition CSR. Speech recognition is increasingly being used in smartphones, whether for voice search like Siri or perhaps to make messaging more friendly to people with challenges. Providing round-the-clock customer service. Traditional customer service representatives are being replaced by online chatbots all through the industry for customer satisfaction. They answer FAQs on issues that have pre-recorded answers like shipping or offer tailored advice, cross-selling items, or recommending clothing to customers, transforming the way we approach consumer involvement across various digital channels. Examples of these AI-powered chatbots include chatbots on e-commerce platforms with virtual personal assistants, chatting applications such as Slack and Facebook Messenger, and duties normally performed by chatbots and virtual agents. Computer vision. It is an artificial intelligence technique that allows machines and computers to generate useful information from illustrations, videos, and many other graphical sources, and then take measures on that knowledge. Image recognition does not have this suggestion capability, but text recognition can. Computer vision uses deep learning techniques, may be used in image annotation on social networking sites, radiological screening in hospitals, and self-driving automobiles in the car industry. Recommendation engine. Artificial intelligence algorithms assist in discovering data patterns that can also be utilized to build more successful cross-selling tactics based on prior purchasing behavioral data. During the payment processes, online businesses can utilize AIs to provide appropriate add-on suggestions to clients. Stock trading. Artificial intelligence AI-driven high-frequency transaction platforms execute hundreds or even millions of deals each day without any need for human interaction in automatic financial markets. Threats posed by artificial intelligence. With possibilities and benefits comes along some threats and demerits. Additionally, the rate at which AIs are being used carries with it a lot of potential risks. Therefore, let us see some of the risks and threats that AIs bring along with themselves. Lack of AI usage has been labeled the biggest danger, with consequences such as poor execution of important programs, a loss of competitive edge in the global market, and worsening economic conditions for citizens. One of the threats can be caused due to misinformation about machine learning by the public and businesses, decaying infrastructure, a lack of innovation, lack of capital, or splintered global marketplaces might indeed contribute to AI's underutilization. Additionally, overuse of artificial can also be stated to be problematic. There are several fictional stories and movies that show that excessive use of AI could lead to analytical skills among humans. A problem with excess investing in AI applications that don't work or utilizing machine learning and artificial intelligence for jobs is considered to be threatening. It wasn't designed for purposes such as explaining complicated social issues or solving problems related to human errors. A significant problem is to find out who is liable for damages produced by AI, operated equipment, or service. For example, in a mishap with a self-driving automobile, who should pay for the damage? Automobile owners, the producers, or the software developer? Artificial intelligence AI has the potential to have a significant impact on the entitlement to the protection of personal data. This may, for example, be used by biometric identification devices or to monitor and profile individuals online. AI makes it possible to combine the knowledge that an individual has provided with the fresh data, leading to outcomes that no one expected. To be sure, AI poses a serious threat to democracy. AI has indeed been criticized for producing digital propaganda that shows only material people want to see, rather than fostering a space for diverse, open, and inclusive national debate. In fact, it could be used to produce deepfakes, which are highly realistic fakes of video, audio, and pictures. These can put the finances in danger, damage the reputation, and make people rethink their decisions. All of this has the potential to create division and polarization in the public eye, which may then be used to influence elections and vote banks. AI might potentially have a negative impact on the right to protest and demonstrate because it could monitor and identify people who hold particular ideas or do specific actions. AIs have the potential to predict human behavior and can be used by organizations to harm the general public. There are countless movies that alert humankind about the world governed by AI. Therefore, despite being very helpful and beneficial for humankind, it also poses a threat. In the following session, we are going to learn more about the future aspect of AIs and the effect they will have on job opportunities. Will AI replace job opportunities in the future? If artificial intelligence integrated into office processes, many jobs will disappear. While AI is projected to generate and improve jobs, concurrently it will start to diminish the job process. However, high skills and knowledge will be essential in preventing long-term recession and ensuring a qualified workforce. It may start a revolution for creating a skilled workforce that compete with artificial intelligence. Some of the average employees would go out of the job, which would not be beneficial for the overall economy of the country. Future opportunities that AI could bring. Artificial intelligence has endless possibilities, and if it is used in a controlled way, it will have many positive aspects. Let us see some of the future opportunities that also AI brings. Use of artificially constructed simulations to study and cure diseases, predicting the course of natural calamities and alerting citizens before it even occurs. Finding the perfect approach to several industrial manufacturing processes that would increase efficiency. Development of humanoid robots inbuilt with AIs for security purposes. Use of AI powered drones and robots for surveillance. Use of AI powered humanoid soldiers to prevent terrorist attacks. Additionally, using these robots on the battlefield reduce the loss of human life. Key takeaway: artificial intelligence is a fascinating field. It has the potential to be revolutionary for humankind. And if it's used in the wrong way, it can even bring destruction to human life. With every technology comes the risk of its misuse. However, if artificial intelligence is used in a better way, additionally limiting its use so that it does not cause any harm to human life as well as jobs. We hope that this was a helpful session for you and you learned everything you wanted to know about artificial intelligence. Subscribe to our YouTube channel to never miss an information video related to different professions, education systems, and courses. Click on the bell icon to receive notifications of our updates.
I'm Vandita Shukla, and we are discussing natural language processing in artificial intelligence. You all must be aware of Amazon's Alexa. Well, it's a voice assistant which understands what you speak and follows the instruction. For example, if you say, Alexa, play Shape of You, Alexa will understand what you've said and will immediately play Shape of You either on your mobile phone or your television set. In case you speak it in Hindi, for example, Alexa, Shape of You bajao, Alexa will understand that as well and play Shape of You. Now, the surprising thing is, how come Alexa understood Hindi and English both? Some of you would be thinking, how intelligent is Alexa? While others, like you and me, would be thinking, how did it actually work? As far as I know, Alexa is a machine, and a machine can understand human language. Is it possible? Yes, it is. And it all happens because of natural language processing. Mind it. What is natural language processing? It's a field of artificial intelligence which gives machines the ability to read, understand, and derive meaning from human languages. So, whatever you say to Alexa, it understands and follows the instruction. It focuses on interaction between data science and human language. So, basically, it means that we are going to train machines to decipher what a human has said and respond in a certain manner. In case you find natural language processing too long to speak, you can also say it as NLP. But is it that easy? No, it isn't. It's a very tough task because, as we know, that there are 6,500 total languages in the world, and each language has its own grammar, own words, own sentences, and each sentence has its own complexity and ambiguity attached to it. A person says different languages with different declarations from different geographies, and it's very difficult to manage and understand the meaning because whatever we speak has loads of information attached to it. For example, the topic or the context, the selection of words, the tone with which we speak, and everything else that adds information to it. All of this is unstructured data, which cannot be mapped to rows and columns of relational databases. Hence, we cannot manipulate it easily, and deciphering meaning from it is a big task. So, how does it work? Now, NLP doesn't go with keywords only, it focuses on meanings more than words. And this is also known as cognitive weight. Now, what are the various steps involved in NLP? As far as I know, that understanding human language would involve a lot of processing. Since there are 6,500 languages, it must be a really, really difficult task to manage such a huge chunk of unstructured data. Well, it is, but it is divided into five basic steps. The first one is lexical analysis. As the figure shows, that we fetch the machine a sequence of characters, which the scanner scans and relates with the symbol table, and parser tokenizes it. All these must sound jargons to you. So, in easy language, let's understand it in this manner that a paragraph has been written over computer or is spoken to a voice assistant. It breaks the paragraph into sentences, sentences into words, and words into their root word. For example, there's the word played. We know that the root word is play and ed suffix. So ed suffix will be removed and we will just catch the root word that is play, which will be called token. Another step is syntactic analysis. In this, we actually check the grammar of the sentences and the word arrangement. For example, a sentence will be broken down into subject and predicate. The subject will be broken down into determiner, adjective, and noun. The predicate would be broken down into verb and the second nominal phrase. The second nominal phrase could also be preposition and noun. And this is how the wise dragon imitates a duck is deciphered as part of syntactic analysis. Semantic analysis involves associating meaning with words. These meanings are not just derived from data sets or libraries, but from the real world implementations or the day to day usages of those words as well. The fourth step is discourse analysis. Discourse primarily means conversation. Now, what happens is, whatever sentence we speak, it might take its meaning from the sentence that we have spoken before and might impart a hidden meaning to a sentence that we might say further. For example, sentence 1 is John took a train to Bill's car dealership. Sentence 2 is he needed to buy a car. Sentence 3 is the company he works for now isn't near any public transportation. Now, he in the sentence 2 is John. How do we know it? Because we see that the only noun being used in sentence 1 is John. Sentence 3, that his company is too far now and there is not proper commutation. This is the reason why he buys a car in sentence number 2. Hence, you can see that the meaning of sentence 3 depends upon sentence 2, and the meaning of sentence 2 depends upon sentence number 1. This is what discourse analysis is all about. And the last step is pragmatic analysis. It's mostly associated with deciphering the sentiment or the intent behind speaking a sentence. Even though the two sentences might sound alike or might have the same meaning, there would be poles apart. For example, John, read the book. It's an assertion. John, read the book. It's an order. John, read the book, please. It's a request. Hence, the way you say it also changes the meaning of the sentence completely. And after analyzing the sentence, after these 5 steps, we come to the conclusion. Now, this might be a little messy for you. So, to understand it, let's take an example. Once upon a time, there was a King Ram. He had 4 sons who were called Prince. Every day, he used to go on hunting with the soldiers. As per lexical analysis, we will break this paragraph into smaller sentences, and these sentences will be broken down into words. The end result would look like once upon a time there was King RAM, and so on. You might also notice that we have removed the redundant words. Well, this is also what tokenizer does. Syntactic analysis was all about associating grammar with the words and detecting the figure of speech. Hence, the end result would look like once is an adverb, upon is a preposition, a is an article, time is abstract noun, and so on. In semantic analysis, we will understand the meaning behind the phrases, sentences, or the words. Now, the phrase once upon a time is used when referring to something that happened in the past. And similarly, we will understand the meaning of the further sentences. Discourse analysis. Once upon a time, there was a king Ram. He had four sons who were called Prince. In sentence number two, in order to understand who is he, we go to sentence number one and see where is the noun. Now the noun is Ram, hence we know that he refers to Ram. This is what is discourse analysis. The last one is pragmatic analysis. Once upon a time there was a king Ram is an assertive sentence. When we analyze all the other, they were also assertive. So we can conclude that it's nothing but a fictitious tale of any king Ram, which may be a fact or may not be a fact. It was easy, isn't it? NLP isn't limited to just understanding the meaning of sentences and their sentiments. It has far more wider applications. Now it's the turn to know where is NLP being implemented in the real world. The first implementation is machine translation. Sometimes we need to know what is a certain word called in a different language. You might just speak it. Alexa, please tell what is beautiful called in Hindi. And Alexa might reply, Sundar. Another example of it is when you want to know what is beautiful called in Hindi. You just go to Google search and write beautiful in Hindi. You can see that beautiful is being converted into Sundar and the meaning underneath is also represented. How did Google search and Alexa understand it? Well, it all happened with natural language processing. Chatbots. In our day to day life, we must be seeing that on LinkedIn, there are certain responses which are automatically given by the LinkedIn software. Or you might be replying to a mail that has been sent to you, and you can see that certain options are available noted, acknowledged, thank you for the mail. All of this come by deciphering the meaning of the email that has been sent or the message that has been sent to you. And this is the work of chatbots. Spam detection. We often tend to ignore that how can Gmail understand which mail is spam and which isn't? Well, it depends on multiple factors. For example, we will see different financial terms, misspelled spellings, wrong email, overuse, bad grammar, threatening language, inappropriate urgency, misspelled company names, and much more. When all these words are searched in a particular mail, it is then understood whether it is spam or not. And this is also done with the help of natural language processing because we here understand the meaning and the intent of the email. Another one is sentiment analysis. As we already know, in pragmatic analysis, we were detecting the sentiment behind it. And the real world application can be seen in social media. In social media, many people write different posts and reviews. And depending upon their attitude, their tone, the selection of words, we determine which post is a troll, which post is an appreciation. And this helps the cybercrime cells to detect the bullies or the criminals present on the social media by the sentiment of their social media posts, responses, and comments. Text summarization. Researchers and many scientists don't have time to read large chunks of data, but it's their job to go through large files of resources and understand the meaning behind it. So, what do? They have these softwares known as text summarizers, which take large chunks of data and result in one or two line meaning of it. How does it happen? Well, it is natural language processing is being used along with natural language understanding, and large chunk of data is then being labeled and a meaning is deciphered from it. Now that we have understood the real world applications, it's important to know how to implement NLP in terms of programs. Or how can you and I build an NLP program? Well, we can do it easily with Python programming language. And one such package of Python programming is NLTK. NLTK is nothing but Natural Language Toolkit. It's an open source Python package for building NLP programs. Since it's open source, so any one of you can use it. It has a collection of libraries, programs, and education resources. And how does it work? For example, you want to have a tokenizer, you want to do lemmatization, you want to understand the meaning. For each and every task, there is a separate library associated with it. You just need to know the library, import it in your program, and implement it. That's how easy it is. And your NLP program will be ready in few minutes. And this was it from our side to decipher what is natural language processing, various steps involved in it, real world applications, and some of the tools. To know more, keep following and liking our videos. Goodbye.
Hello everyone and welcome back to Scalar's YouTube channel. In today's session, we will learn about fuzzy logic in AI, its implementation and so much more. Before that, we request you to take a moment to subscribe to our YouTube channel and hit the bell icon to never miss an insightful update from us. In our daily lives, we face situations where it's hard to make definite decisions in the form of a yes or a no because of the possible lack of information that hinders the process of reaching a reliable solution. Or maybe we get confused between different parameters. Let's take an example. Suppose someone asks you whether it will be cold tomorrow. You will probably not be sure to say yes or no. It is because there is lack of information about how weather will be the next day. Tricky, isn't it? Without further ado, let's quickly move to the agenda to understand what we will cover in today's session. Let's get started. We will follow a top to bottom approach and start with the basics. What is fuzzy logic? Implementation of fuzzy logic. Why fuzzy logic systems architecture, application of fuzzy logic, advantages and disadvantages. With the agenda being clear, it's time to move towards the actual discussion. So let's begin with what exactly is fuzzy logic. The term fuzzy means something which is slightly unclear or vague. There are times when the computer may get confused and does not produce results which are either true or false. As per Boolean logic, the answer can be yes or no, which means it only takes value 1 or 0. However, in case of a fuzzy logic algorithm, it considers all possible uncertainties of a problem that may or may not be beside 0 and 1. The term fuzzy logic was introduced by Lotfi Zadeh in 1965 as he felt that a traditional computer approach was not capable of handling vague data and unclear information. He pointed out that there are endless values between true and false that a computer can incorporate to produce accurate results. These values could be maybe yes, maybe not, can't say, very less, very much, little and so on. Let's understand this through the example we discussed in the beginning. Problem: is it cold outside? According to Boolean logic, the most reliable answers could be yes or no. The Boolean logic algorithm only produces precise results, represented by 0 and 1. However, in the case of fuzzy logic, the answers may have a wider range such as certainly yes, possibly yes, cannot say, certainly no, possibly no. In the case of Boolean logic, it does provide accurate reasoning. On the other hand, fuzzy logic provides an acceptable method of reasoning. The fuzzy logic algorithm takes the best possible decision based on the available data to solve a common problem. Moving on, let's see why the actual fuzzy logic and prefer fuzzy logic over Boolean logic. Unlike Boolean logic, the fuzzy logic algorithm is generally used for both commercial and practical purposes, such as it controls consumers' products and even produces acceptable results, if not accurate, through the available set of information. Therefore, when you say certainly no or possibly yes, though it indicates accurate answers like yes or no, it also gives a sense of confidence that it might be the solution or answer. One of the reasons why fuzzy logic is widely preferred is because if you are not sure whether the answer is yes or no, you can at least find a middle ground by saying certainly yes, certainly no, or cannot say, which helps deal with uncertainty smartly. Now with that, you have understood fuzzy logic in AI and its uses in everyday life. It's time to move on to further discussion and understand fuzzy logic architecture, an important topic. Without wasting time, let's study this topic. Fuzzy logic in AI architecture. When we talk about fuzzy logic in AI architecture, it may seem difficult. However, it's fairly easy. The architecture of fuzzy logic is classified into four major parts. They are rules, defuzzifier, intelligence, fuzzifier. Let's study each one of these in detail to understand the fuzzy logic architecture. Starting with the rules, which contains the most important rules, regulations, and if-then condition presented by the experts to simplify the decision-making system or process. The developments and advancement in the technology have reduced the number of fuzzy rules and regulations in the rule base. Note, the set of rules are also known as the knowledge base. Now, the next thing on the list is fuzzifier, also known as fuzzification, as fuzzification takes place at this step. The role of fuzzifier is to convert the crisp set, a set of elements with identical properties, into fuzzy sets so that the crisp inputs can be easily measured through sensors and passed into controller system for further actions. Further, the fuzzy input is divided into 5 major steps including large positive, medium positive, small, medium negative, large negative. We will talk about this later in the video. Before that, let's discuss the next step. An inference engine popularly called is intelligence solely responsible for determining if the input values are similar to the rules applied. Note, these rules are applied based on the input values received. Further, these rules act as the base to fire action from where we get our fuzzy output set. Note, the inference engine and the knowledge base or rules are together known as controller in the fuzzy logic system. From here, we move on to the last and most important step of the entire fuzzy logic in AI architecture, the defuzzifier. In simpler words, the defuzzifier is the inverse process of fuzzification. Defuzzification converts the fuzzy sets into a crisp value by mapping. There are several defuzzification techniques available and it's up to you whether you select the most suited one. This process is often termed complicated, especially where the weighted average method or centroid method is taken into consideration. To summarize the entire architecture of fuzzy logic in AI, firstly, we have a crisp input going into the fuzzifier where fuzzification takes place. The crisp input is converted into fuzzy input set when then passes through the inference engine. We have fuzzy input set here. Now the fuzzy input set goes through defuzzification where we get a crisp output again. With this, we come to an end of fuzzy logic in AI architecture. Now it's time to move further and understand our next topic, the application of fuzzy logic. Application of fuzzy logic in AI. Today, fuzzy logic in AI is used in nearly every industry. Some examples are automotive systems, environment control, domestic goods, etc. We believe fuzzy logics play a crucial role in supporting the economy and simplifying complex activities. Below, we have listed the most common applications of fuzzy logic based on different industries. Medicine. Fuzzy logic is used to control arterial pressure when administering anesthesia to patients. Doctors consider the fuzzy logic algorithm when diagnosing diabetes and prostate cancer. This is also commonly used in diagnostic support systems and diagnostic radiology. Transportation systems. One of the major applications of fuzzy logic is it is used to handle underground train operations effectively. Another major application of fuzzy logic is it is used to control train schedules. Otherwise, it will be a mess. Stopping vehicles depends on various parameters such as high speed, wheel speed, acceleration, etc. Industry. Fuzzy logic in AI is used to control water purification plants. It is used for quality assurance. Another major application of fuzzy logic is it is used to tackle sludge wastewater treatment. Defense. Fuzzy logic is an essential technology to locate and target people underwater. It facilitates decision making. It recognizes images through thermal infrared. Naval control. Recognizing and selecting optimum routes to reach the destination. Autopilots depend on the fuzzy logic algorithm. Underwater vehicles are identified and controlled through this technology. Now that you understand its applications, it's time to discuss the last point, the advantages and disadvantages of fuzzy logic in AI. Before learning more about the disadvantages, let's quickly look at the advantages of fuzzy logic. Here they are. Advantages of fuzzy logic in AI. The first and foremost advantage of fuzzy logic is its structure, which is exceptionally easy and understandable. So there is no need to scratch your head to understand what fuzzy logic is, as there are just few possibilities that need your attention. Another major advantage is it is widely used for commercial purposes, majorly because its structure and decision-making power. It also helps control machines effectively while dealing with efficiently with uncertainties and complex issues in engineering, as you can easily find the middle ground. Also, there is a need for precise or accurate data, as you can easily modify or alter to improve a system's performance. Another major advantage is that fuzzy logic in AI is inexpensive compared to other technologies, helping you to reduce the overall system cost without much effort. Now that we have discussed the advantages of fuzzy logic, it's time to highlight the disadvantages of fuzzy logic. Like any other technology, fuzzy logic is also prone to disadvantages. One of the major disadvantages is that fuzzy logic is not always accurate due to lack of data or indefinite output. Due to inaccurate result at times, it is not accepted widely all the time, which becomes a point of concern. Also, there is no definitive approach to solve problems using fuzzy logic. Therefore, there are higher chances of different answers leading to confusion. A major drawback for fuzzy logic is that it is not recognized by machine learning and neural network type patterns. The users has to update the rules of the control system regularly. The system requires extensive validation and verification. With this, we come to an end of our discussion on fuzzy logic in AI. Apart from the definition and application, we also discuss major subheads. We hope that this video was useful to you. We would love to hear your views about fuzzy logic in AI in the comment section below. Also, if you have any question about our today's discussion, you can leave them in the comment section below and we would be more than happy to answer them to you. Before leaving, let's quickly summarize our discussion. We started our discussion today with a common fuzzy logic example and introduced fuzzy logic in AI. After studying fuzzy logic, we moved on to the most crucial topic, why do we need fuzzy logic and its architecture? After this, we looked at different applications of fuzzy logic in our daily lives. Later, we studied the major advantages and disadvantages of fuzzy logic. If you like this video, don't forget to press the like button, share it with your friends and families, and subscribe to our Scalar channel. Also, don't forget to press the bell icon to receive notifications every time we upload a video. We will see you next time with a fun, informative video. See you next time.
What is deepfake technology? Have you ever come across videos or photos that do not match the actual videos or picture but left you speechless because how realistic they look? I guess you have heard about the viral Tom Cruise TikTok videos that a content creator made from Belgium, India. Today, we are here to talk about deepfake. This technology manipulates one's individual videos, photos and audio with the help of artificial intelligence so that they seem to be real and all over the place. Let's quickly have a look at today's agenda. What is deepfake technology? How are deepfakes created? History of deepfakes. What are deepfakes used for? How to counter deepfakes. Here is everything you want to learn about deepfake technology. So, what exactly is deepfake technology? Have you ever wondered how is it even possible to replace the human face or the body of the moving object and create entirely new face that have never been seen before? Well, it is possible. The answer to this deepfake technology. Deepfake uses artificial intelligence called deep learning to manipulate the actual images and make images of the fake events. To imitate the work and characteristics of real humans, deepfake creators use artificial intelligence algorithms. It is different from the traditional media as it is tough to identify. Though, this technology came into existence with the aim of betterment, Instead, it has taken the wrong course in the last few years. As the deepfake production methods get better, spotting forged videos or photos become a challenging task. As suggested by its name, deepfake creates fake illusions that are becoming more and more convincing nowadays. The credit goes to the talented creators and power of social media. Though this technology was first used for pranks, deepfakes are now entering the mainstream and are used in movies, shows, and even news broadcasts. Now, when you have got an overview of what exactly deepfake is, it's time we unveil how they are created. How are deepfakes created? Celebrities have found themselves uttering bad words in public places that were never said in real life. Or there have been instances where the forged videos become a point of concern for endless people. Well, this is all that deepfake does. Stitching someone in some other videos or photos they never participated in. Though it initially sounds fun, it is creatively opens door for new challenges. Before landing on pointless conclusions, we would like to draw your attention to how they are created. So, how deepfakes are created? Let us understand together. The creation of deepfakes isn't complex science, whereas it is a process that is mastered with time. The main ingredient in the creation of deepfakes is machine learning that acts as a base for the entire deepfake creation process. Machine learning made the process much easier, faster at a lower cost. Like most recent AI-based applications, deepfakes uses deep neural network architectures to achieve the planned video. To make the video look realistic, the deepfake creator will train the neural network for hours to keep a deep understanding of what the actual person looks like from all possible angles in different lighting. Then the computer graphics will be combined with the trained network to extract the best possible results so it looks 100% real. Though the addition of AI turns this hectic process into an easier task to some extent, it still takes time to yield the process and turn the video or photo into a friction situation that is easy to believe. Number 1. GANs are merged with autoencoders, popularly known for computer vision applications. Number 2. The image is reduced to low-dimensional latent space through an encoder, and a decoder is responsible to reconstruct the image. Number 3. The encoder is responsible for encoding the person you want to imitate into the latent space. Number 4. This latent space then contains the key features of their facial expressions and body postures to enact the body posture and facial expressions. Number 5. Then, a model trained specifically for the target video is used to decode this latent space. Number 6. To improve the results of these algorithms, GANs are merged with such autoencoders. Fortunately, there are endless deepfake making tools available online to extract your creative juices and post on social media sites, including Facebook, Instagram, and YouTube. Now, when you have learned so much about deepfakes, you must be thinking about its origin. Was this technology always present around? Who introduced it? Who made the first deepfake? Well, to get your questions answered, stick by us throughout this video. History of deepfakes. Back in the year 2018, the video of President Obama gained immense popularity and made its way into everyone's DM. By looking closely at the video, one could quickly determine something fishy going on or something isn't a place. The face was right, the expressions was matching, but words didn't seem to be his. It was a deepfake made by Jordan Peele, who put his words into the president's mouth and brought in the revolution. Well, this was marked as the history of deepfake world. But have you ever thought about when this unique but fake technology came into existence? Deepfake technology was invented at the beginning of the 1990s by the researcher at academic institution and later by amateurs in online communities who adopted the latest method to forge videos, photos and audios to create realistic looking fake videos. Over the period, the deepfakes captured the online platforms and creators built a sustainable living out of it. The audience highly appreciate these videos, but their drawbacks are hard to ignore as these spark concern about the potential future uses of the technology and another medium. What is deepfake used for? Regardless of the recorded drawbacks, the deepfake technology gives rise to numerous possibilities and opportunity for the creator and the viewers as they get a chance to interact with the world through their talent. With the rise in technology, the advancements have booked their rooms, already empowering new ideas and capabilities to emerge, giving endless opportunity to talented people. Let's understand some of the positive uses of deepfake technology. Number 1. Education. Audio, video and music have become an integral part of every classroom from quite some time now. The deepfake technology enables tutors to deliver effective solutions and innovative teaching methodologies far more engaging than traditional teaching methods or formats. Bringing the figure to life makes the boring history sessions interesting. Understanding maths with interactive video boosts the learning process. Creative use of synthetic voice and videos promotes easy but effective learning and improves the overall success rate. Number 2. Art. To create compelling stories, many filmmakers, especially in Hollywood movies, uses CGI, VFX and SFX effects to develop artificially but believed effects to enhance the viewer's experiences. Lately, Bollywood filmmakers have also adopted this technology to give a realistic expressions while relaxing in your living room. Entertainment business uses the deepfake for artistic purposes such as adding special effects in the movies, creating forged scenes, making YouTube videos or creating IGTVs. The deepfakes bring back the boring videos or audio to life with the spark of technology. Number 3. Reach and message amplification. The deepfake technology is popularly used among influencers that help them to broaden their reach and increase their audience to a greater extent. Using the deepfake technology, the brand can create numerous videos, audios and photos that look appealing and reach the maximum number of people who sooner become subscribers. It ensures deeper engagement with the fans and delivers specially customized messages. Number 4. Public safety. So, to reconstruct the crime scenes, forensic scenes and art, take the AI-generated synthetic media into consideration that helps to rebuild the scene digitally. In all, deepfakes is an exciting technology that provides excellent opportunities that positively affects our lives. Like every coin has two sides, on the side where deepfakes give expression to a piece of content, it also has another side that is much darker and wilder than you imagined, if not used appropriately. Irrespective of its limitations, it offers endless opportunities to its true users. How to counter deepfakes? There is some deepfakes present on the internet that seems to be real. It is hard to detect whether it is forged or its reality. In other words, with deepfakes, it is easy to trick around. When it comes to deepfakes, there is no single telltale sign to counter deepfakes, but there are several loop points that, if paid proper attention, can make you spot the difference. Number 1. Deepfakes technology mostly manipulates the faces. Therefore, paying proper attention to the face develops on the video to detect any transformation in the expression. Number 2. Look properly on the cheeks and foreheads of the person. Whether the skin is too smooth or to be really or too wrinkly. That does not match the actual age or the grey hair. If you find such differences, then it's a deepfake. Number 3. Another point of attention would be the eyes and the eyebrows of the person in the video. Whether the shadows are in place that you would expect, there are highly chances that things are not perfectly forged as deepfakes often fail to represent the natural physiques in the video or photos. Number 4. Pay proper attention to the glasses. Are they in place? Is there any inadequate movement in the glares when the person moves? Is there too much layers? Well, finding answers to these questions may tell you if the content is real or not. Number 5. Look deeply into the moles. Are these moles precisely like the natural moles on your face? Do they look different? Number 6. Draw your attention upon the blinking of the person. Does the person blink too much or too less to be real? This could be another point of concern. Number 7. Look at the size and color of the person's lip. Check if the size and the color match the face or it goes well with the face. You can also match it with another picture of the person for confirmation. If you spot the difference, you encounter the deepfake. This guide will surely help you to determine if the content is real or manipulated. Though the high-end deepfakes are not easy to identify, one can build intuitions to differentiate between real and fake with time and proper practice. Hope you guys enjoyed the video. Please don't forget to like, share and subscribe this video. For any queries, comment below and we will get right back to you. Thank you. What is deep learning? Have you ever wondered how your phone gallery groups all the images and videos based on their location in just a matter of seconds? Or how a ton of data is processed in almost no time? If yes, then the secret behind it all is a product of deep learning. But what exactly is deep learning? Deep learning is a subset of machine learning, which is in turn is a subset of artificial intelligence, which is a bigger concept in all three. But before diving deep into the deep learning process and its aspects, let us first take a look at what is artificial intelligence, what is machine learning, what are the limitations of machine learning, what gave rise to deep learning, what is deep learning, what are the applications of deep learning, what are the disadvantages of deep learning. Let's begin with artificial intelligence. Before learning what artificial intelligence is, it is more important to understand why we need artificial intelligence. Let's look at a real life example. Nowadays, the moment you break a traffic rule or exceed the speed limit, you get a notification on your mobile phone stating the offense and the fine amount. What do you think? How does it work? Surely it isn't humanly possible to make note of every traffic offense when there are hundreds of cars passing by. Is it even possible to do so where there are millions of cars passing every minute? To solve this problem, there are cameras installed everywhere to capture the number of plates of vehicles exceeding the recommended speed limit. The data is then converted into a text format. This example ties up the concept of artificial intelligence. Apart from this one example, there are multiple areas where this concept is applied. Do you know few people at MIT uses artificial intelligence to predict the future? We are not making this up, and that should give you an understanding of the power of artificial intelligence. Now, let us move forward and understand artificial intelligence by its definition. Artificial intelligence is a technique that simulates human intelligence in the machine and enables the machine to mimic or imitate human actions and behavior. To keep it simple for you guys, our major goal is to have a system and software that can imitate human behavior. Everything that human brains thinks, learns and solve. If you are curious to know how these concepts emerged in the commercial space, do not skip this video and keep on learning with us. To achieve artificial intelligence, there were many technologies introduced, and the first one was machine learning, which we will discuss later in this video. Though machine learning was highly appreciated, there were certain limitations of machine learning that further led to the evolution of deep learning. While the concept of artificial intelligence is not new, it was not given due importance. It was first seen in textbooks in 1856, and years down the line in the 2000s, artificial intelligence and machine learning came to use. the term deep learning was first introduced to the world in 2006 and it brought a revolution. Before understanding deep learning, we first need to look at the machine learning and its limitations. What is machine learning? We all know humans learn from their past experiences and machines follow what human says. But what if we flip the coin and humans train machines to learn from their experiences? For example, if you have detailed data of, let's say, flowers, the machine will recognize what flower it is just by looking and understanding the data. So with the given data, you train your machine to predict a final and reliable outcome. But that's not all. There is a lot that goes into it. We'll discuss that some other day. As today, it is all about deep learning. Let us first understand how deep learning came on board when we already had machine learning. What were the needs or limitations of machine learning that further led to the evolution of deep learning? Limitations of machine learning. High dimensional data. So the number one limitation of machine learning is the high dimensionality of data. Today we have high dimensional data, or let's say data that is generated at a considerable size or number. In such a case, the machine learning model fails, as this technology can't cope with the high dimensionality of the data. Crucial AI problems. Another drawback of machine learning is it is unable to solve the crucial AI problems which include image recognition or natural language processing. Feature extraction. Another major drawback of machine learning models is the feature extraction. In this case, complex problems such as object recognition and handwriting recognition becomes a challenge for machine learning algorithms. Once we have discussed the problem that emerges with machine learning, it won't be fair if I don't tell the solution for these. So let's move forward and understand how deep learning minimized and eliminated these situations. With just a little guidance, the deep learning algorithm can generate features on which the outcome will depend. Also, it effectively solves the limitations of machine learning such as the dimensionality problem or crucial AI problems. By now, you may have got a good idea of what deep learning is, but to make things crystal clear, let me explain this in more detail. Till now, we have studied artificial intelligence and the subset of it, that is machine learning. Since we already know artificial learning is nothing but to mimic human behavior, in the same way, deep learning is in turn subset of machine learning. The idea is the same, to imitate human behavior. Let us understand what deep learning is. Deep learning is a type of machine learning whose functioning is highly inspired by the human brain. In the context of deep learning, this brain-like structure is known as the artificial neural network. Let us understand in detail how deep learning is better than machine learning and how its disadvantages become the advantage of deep learning. To make things more precise, we decide to create a machine that will tell you the difference between tomato and apple. So let us understand this together. If you are using machine learning, you will explain certain features about both so that it can differentiate between the two. These features can be the size, color, or the type of stem of both the data. However, with deep learning, the process is much easier as the features are easy to pick out by the neural network, like the human brain. Here, there will be lesser human interference and the machine will carry out the task with utmost efficiency. However, this type of independence comes with a large volume of data. Let us understand the neural network in detail. The basic idea behind the neural network is nothing but neurons. Now, you must be wondering if we are referring to the neurons that are related to human brain. Yes, you are right. These neurons are the brain cells that are responsible for transmitting multiple pieces of information between different areas of the brain and the nervous system. Neurons have multiple dendrites that are used to provide input to the neuron. As there are many dendrites, the same number of input will be provided. Once the output is ready, it travels down toward the next neuron. Artificial neural network is similar to neurons. We have multiple inputs that are transferred from various dendrites as in human brain. These inputs are provided to the processing element same as the cell body, and later the summation of input until it generates a function of S. Once it's done, next comes the concept of activation function. Now, what exactly is the activation function? If the output is above the threshold, only then will the neuron fire as it fires in the actual neurons. Otherwise, it won't fire. Once the neuron is fired, it will ultimately check the final output. If by any chance the output is not same as the desired output, we will compare the outcomes and find out the difference between them. Based on that difference, we will update our weights and the process will keep repeating until the final output and the desired output are the same. This process of matching the actual and desired outcome is called the backpropagation method. Now, let's learn what deep networks are. Deep networks are nothing but neural networks with multiple hidden layers. There are numerous hidden nodes in the neural network that are interconnected. After that, there is one more hidden layer node where some function happens and it is further connected to the output layer where the final output is checked if it's equal to the desired output or not. If not, then the process is repeated by changing the weights. Where is the concept of deep learning applied? Number 1, customer support services. While engaging with customer support, have you ever wondered how a bot handles the conversation so well? This is because the conversation seems so real that the customer don't even realize with whom they are talking and continue to go on with their problems. Number 2, medical care. Another area where the neural network is deeply applied is in the medical area, where the neural network detects cancer cells to give detailed and confirmed result of MRI. Number 3, self-driving cars. Before the 2000s, have you ever thought there would be anything like self-driving cars? Well, it is a gift of the neural network to humans, especially to the ones who cannot drive. It almost seems like a science fiction comes to life. Number 4, automatic language translation. With automatic language translation, we can convert any language, say Spanish to English and Hindi into German in just a few seconds or even less. To be honest, these are just a few examples I have quoted. There are several examples of deep learning that we use in everyday life and don't even realize. Some of the world's leading companies, including Apple, Tesla, and Nissan, are highly influenced by the concept of deep learning and use it extensively. Though it offers a series of advantages, deep learning also has certain pitfalls that cannot be ignored or overlooked. Let's move forward and discuss the few limitations of deep learning in details. The first and the foremost disadvantages of deep learning is the data. It has been proven that deep learning is the most efficient measure to build unstructured and unorganized data. However, the neural network always requires a huge amount of data to process and work upon. That isn't easy to handle by all devices. Another disadvantage of deep learning is it requires a higher level of training in the neural network. Also, the neural network requires weeks and sometimes even months to train. The time increases with the data and the number of layers in the neural network. So, that is the end of today's session. If you have any queries related to what we have discussed, you can leave your questions in the chat box below and I will come back with the answers for you. Before leaving, let's quickly have an overview of what we have discussed in today's session. We start with artificial intelligence and why we need it. There are certain things that human beings cannot perform as effectively as machine can, with little or no guidance. So that's why we need artificial intelligence in our lives. We also discussed what artificial intelligence is and what are its subsets. I told you, machine learning is a subset of deep learning. In contrast, deep learning is in turn a subset of machine learning that was introduced in 2006 to minimize the various limitations of machine learning. We discussed what exactly machine learning is and why it became the reason for deep learning evolution that eliminates the disadvantages of such a high dimensional data, feature, extractions, etc. We also discussed what deep learning is, the neural network and the various applications of deep learning. I'm sure you must have enjoyed this video and now have a definitive idea of deep learning and its applications. To know more about deep learnings or to explore similar videos, stay tuned and don't forget to subscribe to our channel for timely updates.
You all would have heard the term artificial intelligence at least once in your life. Such is the kind of buzz that artificial intelligence or AI has created. Almost everything in today's world uses AI in some way or the other, be it your daily Netflix recommendations or predicting the stock market prices. With more and more data being generated each day, the need for technologies like AI is now more than ever. Hello guys, my name is Yugendra and in today's video we are going to talk about what AI really is. How does an AI work and how does an artificial neural network work? And lastly, we will implement a simple artificial neural network using Python and some deep learning framework. If you want to know more about AI and its subdomains, there are videos on that as well, for which I will be providing the links in the description box down below. And for more such videos on any new technology, do not forget to hit that like button and it would mean a lot if you could subscribe to our channel. So without wasting any more time, let us jump right into it. So, what really is artificial intelligence? AI is the science of simulating human behavior in machines that are programmed to perform tasks like us humans and mimic their actions. Any machine that exhibits human-like traits such as problem solving and learning constitutes AI. Ever wondered about how a Tesla drives by itself from one place to another without the intervention of any humans? This is possible due to AI. Let us now understand how a human brain works. The human brain sends and receives signals throughout the body. Variety of signals control different processes and our brain makes sense of each of them. Some of these messages or signals are stored in the brain, whereas other signals are sent through the body's huge network of nerves to other parts of the body. To do this, the central nervous system or the CNS depends on billions of neurons or cells in our body. So let us now look at what a neuron actually is and how is it relevant to AI. Neurons are considered to be the basic units of the nervous system. Neurons are also responsible for carrying information all over the human body. There are about 86 billion neurons in the human body, thus comprising an incredibly complex network of communication. A neuron consists of three parts: a soma or a cell body, dendrites, and axon. A soma is a part of the neuron that receives all the information. It contains the cell's nucleus. Dendrites help in transmitting information from other neurons to the soma. These are basically called the input part of the neuron. Axon transmits information from the soma to the other cells. This is known as the output part of the cell, normally ends with a number of junctions connecting the input part of the neuron, which is dendrites, to other neurons. So now, how does artificial intelligence work? The main principle of AI is feeding input data, processing it, analyzing it for any patterns or correlations, and then using these patterns to make predictions or future decisions. Therefore, it emphasizes on three human-like behaviors: learning, reasoning, and realizing. In the learning stage, the main focus is to acquire data and make rules or algorithms as to how we can turn that data into something useful. In the reasoning stage, after defining a certain number of algorithms in the learning stage, we now have to choose which is the best one for the task. In the realizing stage, the algorithms are trained over and over again with the right data to ensure that they provide accurate predictions and make important decisions. We will now see how a typical artificial neural network is similar to that of a human neural network that makes up a human brain. An artificial neural network, or ANN, comes under the umbrella term of AI and was coined to imitate the network of neurons in the human brain so that a computer or a machine can learn things and make decisions like us humans. ANNs are typically a form of deep learning models created by regular computers to behave like they are interconnected cells. Now, how does an ANN work? Structure of an artificial neural network consists of a number of nodes which are loosely designed to compute like that of a neuron in the human brain. Typically, neurons are arranged in a series of layers. The input layer, which receives various forms of data; the hidden layer, this is where the computations happen. This layer consists of many units and its main job is to convert the input data into something that can be used by the third layer, which is the output layer. But when compared to that of a biological neural network, we know that the input is taken in from the dendrites and the output through the axon. Let us dive deeper into the constituents of a neuron, a hidden layer, the output layer, and the weights with a simple daily life example. Imagine you're making coffee. The ingredients that you would need to make coffee are milk, coffee powder, water, and sugar. These would constitute the neurons since they make up the initial part of the process. The quantity of each of these ingredients required constitutes the weight associated with the neurons. The final result is achieved by mixing all the ingredients together in a certain way. This can be called the activation function. Moving on to the hidden and the output layers. A hidden layer constitutes the layer or layers between input and the output layer. It is so called because it is hidden from the outside world. It can be said that the main component of an ANN would be the hidden layer, as this is where all the calculation and processing happens, and finally generate a result which is then passed on to the output layer. In our daily life example of making coffee, the function which regulates the whole process of making coffee is heating. The ingredients now represent the hidden layer. In a typical ANN algorithm, the learning process consists of splitting the data at hand into three different sets: the training dataset, the validation dataset, and the testing dataset. The training dataset allows the neural network to understand and differentiate between the weights associated with each input. The validation dataset is used mainly to increase the accuracy or to fine-tune the performance of the neural network. It is not mandatory, but to achieve higher performance, it is recommended. A testing dataset is used to determine the accuracy of the neural network. Now, implementing ANN with the help of Keras. They will now be implementing an artificial neural network with the help of a simple deep learning framework called Keras. But before that, let us first understand what Keras is. Keras is a high-level neural networks API, or an application programmable interface, which is used to train almost any kind of deep learning model. It is written in Python and it is capable of running on TensorFlow, Theano, and Microsoft Cognitive Toolkit, which is commonly called as C and TK. Keras does not handle low-level operations such as manipulating a dataset, which is usually called tensor manipulation. Instead, It is carried out by well-optimized libraries like TensorFlow backend, Theano backend, and CNTK backend, which also serve as a backend engine for Keras. These backend engines are mainly used for faster computation. We will be using TensorFlow in our demo today. A typical Keras workflow looks like this. The first step is defining your network or a model. In this step, we define the different layers we want in our model and the connections between them. There are two types of models that you can define: sequential and the functional model. The second step is compiling the defined model. In this step, it involves converting the code to a form which is suitable for computers to understand. In Keras, we use the model.compile method. We also define the loss function in this step, which will calculate the losses in our model. The optimizer function, which will reduce the loss, and the metrics used for evaluating the accuracy of the model. The third step is fitting the model or the network. After compiling the data, we fit our model, which in turn is used to train the model on the data. The fourth step is evaluating the said model. We need to evaluate the performance of the network on the same dataset. And lastly, making predictions. Finally, we make predictions using our model on new and untrained data. Let us now see the demonstration. We will be implementing a simple linear regression model using Keras. Let us now start the demo. For this demo, I'll be using the Google Colab notebook just because it's easy to use and it's easy to collaborate with. And also you don't have to install any libraries unlike you do them in Anaconda Navigator. So that's the reason I'll be using Google Colab. And for today's video, the dataset I'll be using is a salary dataset which has experience in years and the salary. So these are the labels. And here we can find the experience in years and the respective salary separated by a comma. So this is the comma separated value file or the CSV file that we'll be using as the dataset for today's demo. Here there's 1.1 and the respective salary is around 3,93,430, and there's 1.2 and the respective salary is around 4 lakhs. Just like that, we have the salary till 10.5 years of experience. So here we have 10.5 and the respective salary is around 17 lakhs 18,720 rupees. And keep in mind that the salary over here is in rupees, Indian rupees. So now let us go ahead with importing the dataset from Google Drive. So for that, the syntax is first you need to connect Google Colab with Google Drive. So from google.colab import drive, and now drive.mount. So this is to connect the drive and the Google Colab. So drive.mount the path, so that's /content/G drive, since it's Google Drive. And now if you execute this, so you get drive already mounted at this particular path. So if you're doing it for the first time, you'll get an authorization URL. So if you click that and then log into your respective Google Drive account, you'll get an authorization code that you'll have to paste it over here. And then if you click enter, you'll get that drive is mounted at this particular path. Since I've already done it, I don't have to do it again. And now let us go ahead with importing the dataset. So that's import. To import a dataset, we use the pandas library. So that's Python and data analysis library. So that's import pandas as PD. Here PD is the alias that we'll be using. And then let us store a dataset in a data frame called df equals pd.read_csv, because it is a comma separated value file. And then now the path will be content Google Drive, and in that my drive, and then it would be salary_data.csv. So that's salary_data .csv. This is the file name that we'll be importing. And now if you execute this, we can see that the data frame consists of this particular data set now. So to show you guys how the data frame will look like, I'll show the first 5 values of the data frame. So that's df.head. It will give you the first 5 values of the data frame. So here we have the experience in years and the salary. So the first 5 values are 1.1 and the salary is 3,93,430, and the fifth value is 1.6 and the salary is 3,77,310. So keep in mind that the index of the data frames always starts from 0. So if there are 5 values in a data frame, the last index would be 4. And now let us store our values in x and y variables. So here, since it's linear regression, x is called the independent variable and y is called the dependent variable, because the value of y, here the salary, depends on the value of x. So that's experience in years. The salary depends on the experience in years. That is what I'm referring to over here. So x would be df of experience in years. So let's copy this. And then y would be df of salary. And now if you execute this, x and y will have those values. And now let us go ahead with the implementation of ANN using Keras. So to import Keras or to import a sequential model, we have this particular syntax. So that's from keras.model import the sequential model. So since the sequential model is what we'll be using over here, so we'll import the sequential model. Sequential model is nothing but a step-by-step model. The output of one step will be the input of the other step, and so on. Now if you execute this, it says, okay, so it's keras.models. Sorry. So now you can see that this code has been executed. Now let us go ahead with defining a model, defining a Keras model or a sequential model. So let us import Keras now, and then let us import the layers. That's from TensorFlow.Keras, importing the layers. Since we'll be using TensorFlow as the backend, we'll be importing the layers from TensorFlow. So that's from TensorFlow.Keras import layers. And now we'll go ahead with defining our model. So that syntax would be model equals keras.sequential, since it's a sequential model. And then the input parameter would be 32, because the number of neurons in the first step would be 32. So that would be enter, and then layers.dense. So remember that dense is a function to create neural network or neurons. So over here we'll keep it as 32 to be the first hidden layer. Will have 32 units or 32 neurons, and the activation function to be ReLU or rectified linear unit, as it's commonly called. Activation is ReLU. So ReLU, what it does is, if the input is positive, it will output the input directly. So that's if say input is 4 or 5, that will be the output. And if the input is negative or 0, it will take it as 0 itself. That is what ReLU does. This is to stop plotting negative values onto the graph or onto the plot. And then input shape would be 1, since the number of inputs that we'll be giving is 1. Over here the number of input we'll be using is experience in years, so that's just 1. So that will be input shape underscore shape equals 1. So this is our first layer or the first hidden layer, and then we'll have 2 more of this, layers.dense comma layers. So let's close this function over here, and this is useless. Layers.dense 32 itself, and now we don't have to give any input. So just the activation is enough. Activation is relu. So that's done again. And now let us give another layer with the same specs. So here we have 3 hidden layers of 32 neurons each. And the activation is relu again. And now, so that's done. And the last layer or the output layer will have layers.dense of just one. Just one. So this is the output layer. And now if you execute this, okay, seems to be the activation spelling seems to be wrong. So let's remove this. And now if you execute this again, we can see that our model is generated. So if you want to, get the summary of the model, that can be done using the model.summary method. So that's model.summary. If you execute this, we'll have the model name as sequential model. And over here, we have the dense layers. So here you have 3 hidden layers. So that's 32, 32 and 32. And the output layer is the last dense layer. So that's 1. And this is how the, summary of the model is. And here also you have that the total parameters are 2209 and the trainable parameters is also 2209. This is, they both should be equal. Now let us move ahead with the optimizer function and the compilation of the model. So to do that, we'll have to import the TensorFlow library. So that's import TensorFlow as TF. So TF here is the alias. And now we'll have to use the tf.keras dot the optimizers. In the optimizers, we'll be using the RMS prop optimizer. So that's RMS prop. So RMS prop is nothing but a root mean square prop method. And over here, the default parameters are given by them itself. And since we'll have to specify our learning rate, we can do that by just giving the value. So that will be 0.001. So the learning rate for this particular linear regression model I'll be using is 0.001. So depending on the learning rate, the model, will perform well or maybe it wouldn't. So learning rate is a tuning parameter that determines the step size at each iteration. So while moving towards a minimum loss function. So the learning rate can be, as you wish. So if you go ahead with, learning rate to be small, it means that the model will perform a better way. If the learning rate is, higher, the model would, perform faster and the accuracy might go down. So let us execute this now. So here we have the RMS prop. So that's done. And now let us go ahead with compiling our model. That can be done by using the model.compile method that we discussed earlier. So, and over here, let us store this in an optimizer variable. So that's optimizer equals tf.keras.optimizers and execute this again. So model.compile, the loss function over here, we'll take it as mean squared error loss function. So that's mean. This is predefined by Python or by Keras. It is predefined by Keras. So mean squared error underscore error. So what mean squared error is? The value or the square of the y prediction value and the y trained value. So it'll be, I'll show it to you now. So here it's mean squared error value is equals the y prediction minus the y value for that particular prediction. So let's say if you want to predict y for 4 years of experience or 1.5 years of experience. So the actual value is 360,000 and the y prediction value might be greater than that or lesser than that. So that is the mean squared error. The square root of that particular difference or the square of that particular difference is the mean squared error. And after that we need to give the optimizer. So that's optimizer equals optimizer. We've already stored that in the variable. And now let us go ahead with executing this statement. So our model is compiled. And now last step or the penultimate step is to fit the model, fit the compiled model. So that is done using the model.fit function. Fit. So we need to fit the x parameters and the y parameters. So that will be x comma y. These are the values that we'll be plotting or the predicting it against. And then the number of iterations or the epochs would be 500. Let's just take it as 500. And now let us, execute this. As you can see that the epochs are increasing over here. So the final epoch would be 500, I believe, because we have defined the number of epochs to be 500. So that is done. And now what we can do is we can use the predict function and predict if our model is, performing well or not. So that can be done using the model.predict function. Let's say if you want to predict the salary for 4.3, so you should give it in square brackets. So 4.3. So salary for the number of years of experience if it is 4.3. So that can be executed now. As you can see that the salary over here is 36,413. I think that's wrong. So let's, increase the number of hidden layers over here. That can be done. Also, since the value is way off the original value, you can increase the learning rate as well. So let's do that now. That can be done by increasing the learning rate. So let us increase the learning rate to the 0.99 and execute this again. Compile the model again and then fit the model again. Let it run for 500 iterations. After that, predict it again. So now let us predict the value. As you can see over here, the value increased from 3,60,000 odd to 75 or 7,55,539. Let us see if this value is closer to our original value. So let us minimize this. So here 4.3 is over here, and here you can see that the 4.3 years of experience will earn around 7,70,810. So what our value is, 7,55,539. So it's almost, similar. So that is how the linear regression is being implemented using Keras. So now I'll show you how to plot these. So for that, you'll be using the Seaborn library. That's import Seaborn as SNS. SNS here is the alias. SNS.scatterplot. So since we'll be using the scatter plot, the plots will be, or dots in the graph. So that will be x equals x. So x equals x and then y equals y. And the data is the data frame, that's df. And now if you execute this, so we'll have model Seaborn has, okay, the scatter plot spelling seems to be wrong. Let us, execute this again. And now we can see that the values have been plotted and the labels have been assigned automatically. So, to fit this line or, to fit the linear regression line using Seaborn, that can be done using the regplot function. So that's sns.regplot, sns.regplot, and the parameters will be similar to this. So let's just copy this and then paste it over here. And now the regression plot looks like this. So there's a line which is being fitted along the data points. So this is the best fit line, as you can see. So let's say if for 4.3 the value would be somewhere around here, so that's around 75 or 7,50,000. So that is the implementation of a simple linear regression model using Keras. You can do many such, models like say logistic regression, multiple linear regression, etc. That brings us to the end of this video. I hope you are clear with how an AI and an ANN work. We mainly have looked at the constituents of an ANN. We looked at how we can use deep learning frameworks such as Keras to implement a simple linear regression ANN model. If you guys liked this video, make sure you hit the like button and don't forget to subscribe to our channel. Thank you.
Hello everyone, my name is Tarun Malhotra. I am a lead software engineer at Interviewbit. Before Interviewbit, I was working at DirectEye. That's about me.
Cool. So my name is Pragya Agrawal and I'm also a senior software engineer over here at Interviewbit. Today's topic is a very interesting topic since you all know that AI is the new thing. So today's topic is going to be, first of all, what is AI and what will be the impact of AI in our lives? So will AI be taking away our jobs, or basically what kind of new jobs will AI create, and how do we prepare ourselves for the future? So yes, let's begin with Tarun. So Tarun, how do you define AI? What do you think AI is doing?
So first of all, guys, as Pragya said, all of us are worried about that, hey, what kinds of jobs will AI take away? But before that, what is AI? What is artificial intelligence?
Is what AI is. So if you look at it from the perspective of the science of AI, right, then AI, the ultimate goal of AI is to basically create something that can mimic a human mind, right? So we are trying to create an artificial brain. That is what artificial intelligence is all about, right? Now you can think of AI from a lot of different perspectives. So one of the perspectives that you can take AI from is basically AI research concerns itself with a lot of things. One of the things is what AI really is. What do we really mean by intelligence in the first place? Like, what are the capabilities of intelligence? How do we produce intelligence? Right? All these things are part of the AI research, and there are some philosophical considerations as well. So, what is consciousness? What is free will? All those different. However, as you can understand, we are not here to talk about those philosophical parts of the AI. We are here to talk about the practical scenario. Basically, what can AI do for us? Right? What are the capabilities of AI, and how will AI change the future as we see? So, leaving aside the theoretical definition of AI, what can AI do? Right? So, yes, sir. Could you tell us what AI from a practical perspective?
Yeah, so basically AI, artificial intelligence, trying, as the name suggests, that you are trying to generate intelligence which is artificial, which is not human. As of today, historically, we have been trying to look at intelligence from a human prism. We have intelligence, we are intelligent, we can look at data, figure out patterns, take some decisions based on those patterns, and trying to figure out that, hey, that is what we have always called intelligence. Now, AI is that you are trying to recreate that by using the computation power of your computers and trying to figure out those patterns and predict outcomes based on that patterns, or in a way, structurally trying to mimic human intelligence and making machines capable of that level of intelligence, or maybe an intelligence which is beyond our human intelligence also. So that's what AI is for me.
So what we can do is we can draw analogies of AI with what kind of technical revolutions we have seen in the past. So one very interesting thing that we have seen in the past is the Industrial Revolution that began in the 1760s and so on. So yes, we did see a lot of new technologies come up in the Industrial Revolution. So perhaps could you talk about that, Tarun?
Okay, so first of all, guys, all of you would have heard about the term Industrial Revolution. Industrial Revolution essentially is the revolution which actually gave us these machines, these steamed power machines, and actually ended up in automating a lot of things that were done by hand before. But I will actually give you a much more deeper perspective here, and will try to actually tie that with this new revolution that is going on. And people actually call this the fourth industrial revolution. So actually, before coming to the fourth industrial revolution, let's try to imagine the history, our past, and see how all these industrial revolutions actually changed things drastically. So the first industrial revolution, as Pragya said, was in the 17th century or the 18th century, is the industrial revolution which actually gave us the steam powered engines. And that is when, back in the day, the textile manufacturing was entirely by hand. And that first industrial revolution totally replaced that hand woven clothes and gave us machines that are going to create our clothes. This had a massive impact and led to a much higher level. We actually went to a much more optimized world where things could have been done at a much larger scale, which you could not have imagined earlier. Then the second industrial revolution, which is also known as the technological revolution, happened when the world actually saw the invention of a telegraph. So people started building these great networks where people can talk to each other far off to each other. And then they also started building extensively the railroad network. That is, you can very easily transport yourself from one place to another, and also via telegraph. You can also communicate your ideas, that is, transfer your ideas to much larger geographical regions. Now, the second industrial revolution, also changed the way we have been living, right? It actually drastically changed things. Early on, if you can't actually move very quickly to different parts of your country, what would really happen is that there are some centers of all the innovation, some centers of all the trade, and some centers of all the education also, and everything beyond the geographical reach was a place where not a lot of things happened. But with this industrial revolution, things changed a lot in that aspect. Now, the third industrial revolution, which is very closer to us, we know a lot more about that as of today. We actually appreciate that a lot better, is the digital revolution that happened. These computers, which actually started doing a lot of logical tasks for us and doing a lot of computation using these chips. This is the third industrial revolution. Now, this fourth industrial revolution is actually the AI revolution, where not only some computations can be done using machines, but you can also hope to deduce a lot of inferences using these machines. So basically giving machines the data and asking them to figure out more about that data, figure out patterns in that data, and then trying to also predict things. This is what the fourth industrial revolution is, and very similar in a lot of sense to the previous industrial revolutions, but also very different in some aspects. So Pragya, I would want you to add in your 2 bits on how is this revolution different, let's say, from the early 3 revolutions that I talked about, and then maybe we can also discuss about how this can also be seen very similar to the earlier revolutions.
So you have already drawn the analogies with the past. So basically, the AI revolution can simply be seen as a continuation of the previous industrial revolution, right? The previous 3 phases. However, there are still a lot of dissimilarities. Right? So we have to understand that earlier in the industrial revolution, what was being automated was the labor-intensive part. Right? We were automating power. We were automating mechanical things. Now, what the AI revolution will allow us to do is, it will allow us to automate the process of thinking itself. Okay. And thinking, if you look at it from the perspective of the things that we can do, thinking is the center of the human being. Right? So everything that we do, everything that is logical that we do, everything that is creative that we do, the science that we do, and even the very human connection that we establish with each other, right? The kind of emotional bonds we form, all that stems from our capability to think. Now, because the AI revolution is going to automate this AI thinking, basically what we will be able to do is, we will be able to put all these human traits of logic, science, even the human connection into a machine, right? And maybe, perhaps we will be also able to make that machine much, much better, 10, 100, 1,000 times better than the humans, right? In achieving these things, right? So even though AI revolution is simply a continuation of industrial revolution, this might perhaps be one of the most significant bits of the industrial revolution. Because the kind of impact, the kind of life changes in the society that AI revolution will bring will be very, very drastic.
Pragya, I would just want to add one thing here. Of course, this revolution may actually take us to a world where rate of change is going to be very, very high. We all appreciate that. But there is also, I would want to point another underlying similarity. So the rate of change today seems to be very, very high with this fourth industrial revolution. But if you try to imagine the kind of world that was before the earlier industrial revolutions also, you would realize that actually the world changed a lot with those revolutions also. But now when we look in hindsight, it seems that, hey, it was a small change, but that was a small change only because where we are today. But if you look at the perspective from that time of the world, then you will realize that maybe the changes then also were very, very huge. For example, just imagine that if there were no machines whatsoever, right? If there are no machine, the humans can actually hope to be most productive by doing laborious jobs. You actually farming yourself by hand. You producing goods yourself by hand. That seemed to be the most outcome-driven work that you can do back then. But with the machines, that changed. Our perspective changed. What we feel is important changed because there are a lot of things that can automatically be done. Similarly, today also, the things that are very important to us today, the jobs which are very well paid today, may change drastically in the next few years, given that our machines are getting more and more intelligent, and a lot of things that seem to be very, very optimized usage of our time today may not be the same as we look a few years later. So that's very, very important to understand.
That's right. So basically, talking more about this point, you said that most of the jobs that we thought were productive way back in the time before the Industrial Revolution, after the Industrial Revolution, we realized that those jobs are perhaps not the most productive use of our time. We can invest our time much better in some other job. So if you look at it from today's perspective, what kind of jobs do you think the AI revolution will take up? So the title of our video is that AI is guaranteed to take away some jobs, right? That is beyond question. AI will definitely take away some jobs. What kind of jobs will AI take up first? So yes, what do you think, Tarun, about that?
So the best way to look at this would be to look at the jobs that are already being taken away by AI, right? So the first thing that I would want to talk about is the warehouse jobs. So today we have the Amazons of the world delivering millions and billions of packages all throughout the globe. You would realize that we're housing those packages and then sorting those packages to make sure that you are delivering the right package to the right place. That involved, before this fourth industrial revolution, that involved a lot of manual labor. Today, if you look at the warehouses of these big organizations, you would see that 90% of the job is actually automated. There are humans, but most of them are just supervising, making sure that there are not some exceptions that happens and how do you handle those exceptions. And also then doing some interface job. That is, a lot of work is done by the machines, and you just act as an interface and get the things done, take them to completion. So of course, warehousing jobs are being replaced as we speak with artificial intelligence. The next kind of jobs that I would want to talk about is the jobs of, let's say, customer support. You calling somebody in a call center, trying to get your job done, asking them your doubts, telling them about, hey, why is this not working? How should I get this to work? This happened to be a very big employment opportunity for us. And this was a good use of your time because you are now assisting others to use a product that you have created. But now this is a job which is being disrupted by AI at a very, very big pace. You would see a lot of companies out there in the world today trying to build these chatbots, trying to automate the experience of users and automatically trying to figure out that, hey, what's the right resolution for this particular use case? So all of us are using Swiggy. All of us are using Zomato. Today, if you order something on Swiggy and you realize that, hey, the order is not as per my requirement, the first thing that you do is you actually go to a chatbot. You don't actually get connected to a human immediately. You go and talk to a chatbot, and only in some exception, you actually talk to a human because most of your otherwise interactions can be handled by a machine itself. So yes, all the jobs, and if you try to understand the pattern behind these jobs, so I talked about two jobs right now, warehousing, I talked about, let's say, customer support. Let me also talk about one more job because then the pattern will become much more evident. And Pragya, then maybe you can add your ideas on the same. The third job that I would want to talk about is the business of underwriting risk. So I will just talk a bit about what do I mean by underwriting risk. So whenever you buy an insurance policy, right, you go and you try to buy a life insurance policy, you try to buy a health insurance policy, the companies are trying to assess what kind of a risk profile do you belong to. And based on your risk profile, do you smoke, you don't smoke, how healthy is your liver right now, how healthy is your heart right now. Based on that, they will try to estimate how long are you going to live. And based on that, they will decide what kind of a premium they would want to charge you so that they can balance this risk. Now, this is a job which requires you looking into lots and lots of data, trying to make sense out of the data and trying to look at patterns in that data and then figure out that, hey, what kind of a risk profile this particular individual belongs to. Now, this is also a job which I am pretty sure will be automated massively in the next few years. Already we are seeing companies emerging in this space which are trying to automate all. Now, if you look at all these three things together and try to look at an underlying story that what kinds of jobs are these, what is the underlying pattern amongst these jobs that AI is very easily being able to automate today, you will understand that all of these jobs are essentially you trying to make sense out of a bunch of data points, right? So you have rich data available. You earlier required a human person there to figure out this particular instance belongs to which part of my data landscape and how can I solve this issue based on how this was solved in the past, or what does the FAQ document tell me to solve this based on. Now, This is basically you looking at an instance, trying to do pattern recognition, and then trying to answer how to do it. If you look at all three jobs, warehousing, that is how do you transport a packet from here to here? What is the best route here, and how can you use machines to transport data within the same warehouse, or let's say outside the warehouse as well. And similarly, if you look at underwriting risk jobs, or you look at these customer support jobs, you will realize that you required a human to look at an instance and trying to figure out where does this instance belong to, and then coming to a resolution. And now AI is very easily being able to remove these jobs and automate these jobs. So the idea being that if there are some repetitive jobs that we as human race is doing, those jobs can be the first jobs that can be automated.
Cool. So the repetition part that you spoke about in the last, that is perhaps the key point over here. So it is not about how skilled a job is. It is kind of a misconception amongst people that only the low skill jobs. I'm not really sure how do you define a low skill job. What is a high skill job? I mean, there's no job which is unnecessary. However, people still kind of believe that low skill jobs are the first jobs that are going to be automated, which is not. A job that is going to be automated, that is more likely to be automated, is a job that has a lot of repetition in it. For example, let's imagine 50 years before from now, if you wanted to send a postcard, if you wanted to send a mail to someone, then there had to be a human that had to read the description, that had to read the address on the postcard, and they had to basically route it to the correct person. That okay, this postcard must be filed in this particular cabinet because it is going in this direction. Now, thanks to AI, this is kind of a repetitive job, right? You read something and you put it in the right place. That job is very easily automatable. And if you see, almost all the postal mailings nowadays, almost all of these things are completely automated by technologies like OCR and basically handwriting recognition technology. Right? Other than that, there are several other jobs. For example, the job of a cashier or the job of an attendant. Right? What is the major job of a cashier? Person comes to you, you hear out what the problem of that person is, right? Similarly, the job of a customer support executive is the same. A person comes to you, you hear out their problem, and you direct them to the correct resolution. Now, this is a very repetitive job that can be automated. So, these are the kind of jobs that will be automated. Apart from that, in the job world, where people see that, okay, these kind of jobs, programming jobs, people believe are very high skill jobs. However, there's a lot of room for automation even in the programming jobs. For example, if you become a machine learning engineer, one of the first things you learn is things like what is linear regression, right? And you try to learn things like that, okay, if I have a data set like this, then what sort of model should I choose to basically get a good result on this data set? Right? Now, that seems like a very high skill job, but in fact, it is not. And if you see, most of the companies like Google, like Amazon, they are working on auto machine learning techniques. Right? They are launching solutions in which you simply upload the data to their servers, and the AI will choose the best model for your data. The point I want to stress over here is that is this repetition, it is the lack of creativity in a job that makes a job more or less susceptible to automation. Okay. Now, there is one more thing in there which is important that we talk about. Even when we talk about artificial intelligence or lack of repetitive jobs, there's a lot of spectrum in these. Some jobs require only thinking. For example, routing a particular mail, that requires only thinking, reading something and making a decision. However, there are some jobs that require a lot of hands-on activity. For example, if you consider something like a surgeon or something like a hairdresser, the hairdresser is not really doing something very intelligent. However, the kind of skills that hairdresser requires, those skills need very fine motor control, right? Very good eye-hand coordination, very high dexterity, basically with respect to the hands of the hairdresser. Now, even though the AI revolution is taking at a very fast pace, the revolution that is with respect to mechatronics, right, robotics and controlling things, moving things around, right, that is still lagging behind a lot. So these things will still take, the hairdresser job will be automated eventually, but it will take much more time to automate those kind of jobs than jobs like programming. So as Andrew used to say, that I know how to automate a programming job, but I don't know how to take the job of my hairdresser.
That's a very, very interesting point that Pragya you raised. I would actually want to go back a bit on this point and actually hammer this point across, because this should be very, very interesting to our audience. Our audience is primarily programmers. And now what they have just heard is that probability of AI placing the job of a hairdresser is much lower than the probability of AI replacing a job of a software developer. This seems very interesting and maybe also a bit depressive also, that maybe you should maybe become a plumber or a hairdresser today if you want to have a job in the future. But now, let's talk a bit more about that. When Pragya said that, hey, the programming jobs can be automated, of course they can be, But it's very important to understand how can you sail through this transition without you personally getting hit. Now, in a programming job, there are multiple aspects, right? The first part is that, hey, what most of us actually usually do is we build some APIs, we build some CRUD applications, right? Now, building a very simple API where you would want to pull out data from one side and then show it in a view somewhere else. So basically building these basic API is a job or a part of the job that you can also imagine is very repeatable in nature, right? You just need to repeat a few steps over and over again every single time. Now, this is a job which is perfect to be automated. AI can automate this very easy. But at the same time, there are some other parts of a software engineering job that will not be that easy to be automated. For example, a software engineer also needs to architect systems, right? You need to architect systems. You need to figure out that, hey, how will my system handle scale? What kind of a layer do I want to introduce? Do I want to cache some of this? Do I want to store this in what kind of a data store format? How do I want to retrieve it? And basically trying to build the architecture of a system. This part of the job is not very repeatable. You just can't look at system design of YouTube and say, I'm just going to copy that verbatim while building a new application. You will have to make tweaks. You will have to come up with new designs with each and every problem that you are solving. This is not going to be very easily replaced by intelligence. And when I say this, please bear in mind that we are talking about the next 10, 12 years. We are not talking about the next 200 years. In the long run, all of us are dead, right? So let's not talk about what happens 200 years from now or 100 years from now. But let's talk about what happens in the near foreseeable future. If you are a software developer and you want to make sure that your job is not going to be automated in the next 5 years, you should invest in upskilling yourself in the skills that are not very repeatable. So how do you design a system? And also, let me talk about one more aspect here. So a lot of us are product engineers, right? So we are the owners of a product, a small product, and we also code it. We also build it up. Now, building it up will require, again, two kinds of things. One thing which is very, very repeatable, most likely that will get automated. But then there's the other part. That is what to build, how to build, why to build. Maybe talking to a bunch of hundreds of your customers, trying to figure out what exactly your product can help them solve. Now, this is a job which is not going to be automated by AI very soon. Of course, you have a technology, but how do you leverage that technology? What do you build using that technology? There is where human ingenuity, human intelligence is required, and you should ensure that you're upskilling yourself in these skills so that you don't become irrelevant in the next few years. That is very important.
Fair enough. So, I usually give this analogy in my classes a lot. There are basically two types of programmers. One of the programmer is a typist, right? Their primary job is to take some specification and to convert that into. The second type of programmer is a thinker, right? They take a problem and they figure out how to solve the problem. Now, what you have to do is you have to become the second kind of programmer, because the first kind of programmer is going to be automated in the next 5 to 10.
Absolutely. There is where upskilling becomes very, very important. Because if you look at the mix of software engineering jobs out there are millions of software engineers. But in reality, a lot of us are not doing the second aspect. A lot of us are just focusing on what Pragya called a typist job. That is just getting some things done, a very, very repeatable process. You know how to code this up. You just create a few APIs and get done with it. This is a typist kind of a role. And a lot of us are actually in this kind of a role. We need to transition from this and move up this skill ladder so that we are not just doing this repeatable job, but you are actually bringing something more to the table. You are not just typing a few lines of code, but you are ideating what to build, how to build, and that becomes very important. That is when you become least replaceable. And just to add one more point, guys, even if you forget about AI for a minute, if you want to become a software engineer who is very much cared for by your organization or very much all the companies trying to hire you, the kind of software engineers that people would want to hire are the folks who are problem solvers. You can give them an abstract problem and they can solve that problem to you. So that is what you should ensure that you are defined by. You are a problem solver. You are not a coder. You are not here to just copy 5 lines from Stack Overflow, copy them, run them, solve a few bugs and get done with it. You essentially are a problem solver. If you make yourself a problem solver, you can be much more respected and wanted today. Also, you will be at a much better place to overcome this tide of AI and artificial intelligence replacing jobs. You can still remain relevant. So that's the basic point here.
Cool. So basically diving further into this, if you look at the kind of things that a software engineer is expected to know, right? The kind of subjects that a software engineer is expected to master. So subjects like learning about frameworks, learning different tech stacks like Python and Django, or Java and Spring Boot, or React and the Merge stack and things like that. There are other things that a software engineer is required to do, things like knowing data structures and algorithms, right? Knowing about system architecture. So Tarun, what do you think out of this spectrum of the kind of skills that a software engineer is required to do, what kind of skills are the most important? What kind of skills are the skills that people should invest learning in today so that tomorrow their jobs are more future-proof?
So there is a question: which new software engineering roles related to AI will be in demand in the future? So this question has two parts. First of all, what are the skills that we see today are very important? What are the evolving skills that may become very important as we move along? That is, how can AI bring in a lot more skills that you should master? And the other part is, what are the skills that are relevant today will become a lot more relevant in the future because of the advent of AI?
So basically, if you look at AI jobs are basically, you can dissect them into two major categories. Right? One of the jobs is kind of the research job, and the other job is kind of the implementation job. In the research kind of job, what you try to think is, you try to research the nature of artificial intelligence itself. You research different models that, okay, if this is the kind of data, then what kind of model performs best on that? Right? Coming up with things like neural networks, coming up with things like convolutional neural networks, right? Researching things like generative adversarial networks, all these things, they are part of the research of AI. On the other hand, we have the implementation aspect of AI. Right? The implementation aspect of AI deals with that, okay, I know that these models exist, but solving a real life problem is much more than simply talking about the theoretical perspective of it. Like, so I have to understand where I'm getting the data from, how do I clean that data, how do I make sure that the models that I'm applying, they actually are performing well in practice, and my customers are getting what they really want, right? There are two parts of this AI field. Now, in both the parts, there are some jobs which can be automated, and there are some jobs which are more difficult to be automated. If you look at it from the research perspective, there's a lot of people that are coming out nowadays which are not doing any innovation. They are simply saying that, okay, we have this kind of problem. Nobody has applied this model on this problem, so let's apply this model on this problem. Let's see what the result is. Let's just publish that. That is something that is highly automated. So you can expect in the future that those kind of research activities, those kind of jobs will be reduced in the near future. The new jobs that will come up in AI will be the jobs that research new models, right? Okay, what sort of new idea can I come up with that is going to help improve my model, right? So drawing analogies or drawing inspiration from the nature, just like we have convolution networks, drawing inspiration from the way our basically visual cortex works. Jobs like this will be more in demand. Similarly, if you talk about the practical aspect of artificial intelligence, the jobs that will be created in the near future will be jobs that will be looking at, given a particular problem, what sort of model or what sort of decisions should I take? The kind of problems that require you to architect the solution and not just code the solution. So you can expect that all these frameworks that you currently hear about, that, okay, should I learn TensorFlow? Should I learn something like PyTorch? All those jobs are going to very quickly become irrelevant. The jobs that are going to remain relevant are the jobs that require you to understand the basic principles behind artificial intelligence. What is linear regression? What are neural networks? How do they actually work? The theoretical aspects, basically the understanding, the deep understanding of those things are going to be relevant in the future jobs. So I hope that answers the question. Is there something you would like to add to this, Sarun?
No, absolutely, Pragya. But I would just want to hammer across the points again. A couple of points here which I would just want to highlight, but you covered exhaustively here. Guys, as Pragya said, in research, so for example, AI, there are two aspects to AI, right? You would want to research new and new models, and then you would want to implement those existing models and tweak them to solve a real life problem. In both directions, you have some jobs that are very repeatable and can be automated very easily. For example, if you look at the folks who call themselves, let's say, data scientists, you look at and try to figure out that, hey, if you try searching LinkedIn and try to find out for jobs that are out there in the domain of machine learning, you would see a good proportion of them actually over-indexing on you knowing a particular framework. Hey, can you build a model using TensorFlow for me? Can you implement this for me? Those kinds of jobs are going to be very easily replaced, very easily automated. On the other hand, the other side of implementation, where you actually figure out how to tweak this existing solution to solve for a real life problem. This is an abstract model. How do I tweak this? How do I configure this? Maybe how do I use multiple models in conjunction to solve this problem? That is where the architecting part is going to remain relevant for a long time. If you want to become a machine learning engineer, you rather should focus on problem solving. That how do I use this to solve a problem, and not over indexing on a bunch of frameworks that, hey, I know this framework, I can code this up, I will read a research paper, I will just recreate that model here. That's all about my job. That is very easily replaced. At the same time, there is a wrong notion in folks that, hey, the research aspect of machine learning, the research aspect of AI, you can't automate that. But as Pragya rightly pointed out, there is a good chunk of human effort that actually goes in research where you just try to explore multiple configurations of the same model. You actually try running it through different configurations and then publish a paper that, hey, these are the results that I just got out of this configuration. Now, this is a very repeatable job. If you find yourself doing the same steps again and again and hoping for a new outcome that you can publish, these kinds of jobs can very easily be replaced. On the other hand, thinking from ground up, leveraging the basic fundamental mathematical machine learning principles and coming up with a new model altogether, coming up with a new way of looking up for patterns, that is something which requires human ingenuity. That is something which requires human intelligence, and you can't just replace that very easily. So irrespective wherever you are, in what segment, in what vertical you are currently, try to ensure that you move towards more intelligent aspects of job rather than the repeatable aspects of jobs, because knowing and being good at those repeatable stuff is only going to help you for a few years at most. It will not build a strong career for you for the next 20 years. I am very certain for that. That is what we should all keep in mind, that, hey, what are the skills that require intelligence and what are the things that just require repeatability? Move towards the skills that require intelligence.
So maybe what the viewer was trying to ask is, what is the future prospect of machine learning jobs? So one thing that I would also like to point out over here is that if you look at the global supply and demand of machine learning engineers, there's a huge shortage of machine learning engineers in the world right now. Right? I mean, if you look at places like Silicon Valley, if you look at places like Bangalore, the IT hub of the world, there's a huge demand of machine learning engineers, and the demand is so much that companies are struggling to meet that demand. They're struggling to hire good quality machine learning engineers and good quality software engineers that they actually want. So if you look at it from the perspective of the next 5 to 6 years, even though we are talking about AI automating a lot of jobs, AI taking away a lot of jobs, in the next 4 to 5 years, you will only see an exponential increase in the number of machine learning jobs that are available in the industry. Investing in learning machine learning right now, that is still a very good endeavor. That is something that is going to secure your future for a long time. However, while you are upskilling yourself in machine learning, just keep in mind that don't upskill yourself only in the frameworks. Upskill yourself in the problem solving part as well.
Absolutely. And if you can, as Pragya rightly mentioned, as of today, there is a lot of demand even for people who just know a few frameworks, who can code things up. But what the right way to look at it would be that, hey, I can maybe use that opportunity to get a foot in the door. I can use that opportunity to get a relevant job, but then it becomes very, very important for you to upskill yourself in the right skills so that your job does not become irrelevant in the next 10 years. So absolutely, it's very important to make sure that you don't get us wrong. It is not as if learning TensorFlow today is of no use. It will help you a lot. It will get you several job opportunities because there is a big shortage for companies trying to figure out people who know those skills. But if you use that, just use that to get a foot in the door. But then it becomes very, very important to make sure that you keep on upskilling yourself. If you feel that, hey, I got a job because I knew this framework and this is what is going to help me throughout, maybe you are mistaken. And if you are in the AI domain, maybe you know it best that, hey, that we are mistaken here. Just knowing this framework should not be. Similarly, I would just again talk about software engineering because there are so many people here who are software engineers. Guys, today, there is a big dearth of software engineering talent, right? You talk to any startup founder, the single most important resource that they will talk about is that, hey, I have capital. There is, because of the Fed, the US Fed, you have so much capital out there in the world. Capital is very cheap. But the thing which is most difficult to find right now is tech talent. And a lot of that aspect is just knowing coding. That, hey man, this person is good in Java. He can code. I can tell him what to build. He can just build that for me. That's great. But don't assume that that is going to stay as it is for the next 20 years. You can use that opportunity to get into the door, get into a good organization, start contributing, but make sure you don't stop there. Because if you stop there, then there is a very high probability that you will become it. But if you use that opportunity to then start tinkering with that, hey, how are products built? How is this architecture architected? Maybe I should upskill myself in understanding that, hey, what's the best architecture for this problem? Maybe I should contribute that, hey, you should change this caching layer. Maybe you should introduce a new kind of a caching here. Maybe that will help. Making sure that you move and do that transition is very important. And all of us should be cognizant of that.
True, true. And basically, there's one thing that I would like to mention over here. So you talked about upskilling, right? And this is going to be a very common thing. Upskilling is going to be the common theme of the future. So if you look at jobs today, people don't really invest a lot in upskilling themselves, in learning new technologies, in learning new skills. We're not just talking about software engineering jobs. We're talking about new skills in general. So you are going to notice that in the near future, learning new things, being able to quickly change your domain, basically quickly be able to switch from doing something to doing something else, picking up new skills very quickly, that is going to be a central theme. That is going to be a central skill that people will need to acquire in the near future.
Let me add one thing to what Pragya just said. Of course, the agility of learning new skills is very important. You need to upskill yourself, keep on learning new skills. Another thing that I would want to point out is being at the edges of two domains. For example, that, hey, you are a great software engineer, but you also understand human psychology very well. Just an example. Similarly, let's say you are a great software engineer or you are a machine learning engineer, but you also understand finance very well. Being at the conjunction of multiple skills, this is, in my opinion, going to be a very, very highly rewarding journey to take. For example, if you are very good in one skill, do try to look at that, hey, what are the ancillary skills, maybe in different industries that I can pick up, and then move to a very, very important position where I know one domain very well, but at the same time, I also know a few things about a different domain, and I can work at the very edges, the contours of those two domains and do something great. That is going to be very, very respected and very, very required in my opinion, guys. So, what are the prerequisites in order to learn machine learning? What are the things that you should first of all focus on?
So, machine learning, if you look at it from the academic perspective, machine learning is not a very difficult skill to pick up. If your aim is to go into the strict research part of machine learning, if you're saying that, okay, I want to perhaps do masters in machine learning, or I want to do PhD in machine learning, I want to basically end up in a research profile, you need very good skills at mathematics. Right? What kind of mathematics subjects I'm talking about? Subjects like linear algebra, right? Subjects like statistics and probability. Right? These are some things that you definitely need a lot of skill. I mean, a lot of people, I understand, they're kind of afraid of maths. They're kind of shy of maths. However, if you build these foundations in a solid manner, that will help you a lot in basically preparing for machine learning. Then, if you don't want to take a research kind of position, if you don't want to very skill in things like probability or linear algebra, then you can also look at machine learning and AI from the perspective of a framework of solutions, right? Just like Lego blocks. So basically, when you are building a structure out of Lego, you all have played with those Lego blocks, right? You have bricks. Those bricks have something poking out of them, and you can basically fix one block on another. So you can treat AI in a very similar manner. You can take common solutions that are applied to problems, and you can use those common solutions to tackle a bigger problem, right? You can figure out, okay, what solutions or what kind of structure, what kind of organization do I put these different solutions in to solve my bigger, larger problem? So if you look at it from the academic perspective, you can take either of those channels. You can either become very good at things like linear algebra, mathematics, statistics and probability, and then start learning about the basics of machine learning, things like linear regression, things like what SVMs are, right? Things like what different kind of problems are, things like what probabilistic models are. Or you can take the other approach and you can start learning different ways that people are applying these different models to different problems.
Yeah, just to add one thing here, guys. So, as Pragya said, that linear algebra, understanding probabilistical models, these concepts of maths are very, very important for you to become a good machine learning engineer. And some of you, as he said, that are shying away from maths, that, hey, this is too abstract for me. I would not be able to understand this. Maybe I should not pursue that. Let me tell you one thing, guys. There is a big static friction there that it looks very difficult at the very beginning. When, for example, if you're starting with linear algebra for the first time, you will feel that it is very difficult. It is difficult, to be honest. But then if you spend enough time, after a couple of weeks or a month or a two, when you start appreciating things and when you are able to identify unstated patterns, when you're able to identify and understand things at a intuitive dimension, things become very simple. So if you are scared of linear algebra today, my advice would be please try to invest, let's say, a month at least on it. And after that, there is a big probability that you will start finding it a lot more intuitive and you will feel that, hey, you can do that. From the outset, it may look very difficult. For the first few weeks, it will look difficult, but do give it a try. In my opinion, having a good grasp of these basic mathematical concepts is very, very important for a machine learning engineer, irrespective of what you want to do. Of course, the degree of your understanding may vary if you want to do research or if you just want to play and tweak these things to build a solution to it. But I would say that understanding these things, in my opinion, is very, very important. So should not shy away from it. Invest time. You will be able to do a lot better with that. That's my suggestion.
In fact, I would like to say something even more stronger at this point. So I truly believe this fact that if you are weak at mathematics or if you are scared of mathematics, it is not your fault. The fault is of your teacher, whoever taught you that particular subject. Right? If you're weak at mathematics, if you're weak at logic, then most likely you have not had good teachers in your life. Now, it's okay, right? Not everyone is fortunate to have enjoyed the support of the best teachers. I personally have done my education from both a third-tier college in India and the best college. So I'm speaking from experience. I have perspective of both the sides. The difference that a good teacher can make, like a teacher that really cares about your learning, the teacher that can intuitively explain a particular topic, the difference that a teacher can make in your understanding is huge. So if you are feeling shy of mathematics, what I would like to say is don't give up just yet. Just try out some other resources. Just try out some better resources. There's a lot of resources, free open resources like ocw.mit.edu, right? MIT's open courseware, a lot of courses online that Stanford provides, a lot of hands-on training that companies like Scalar, right, like we provide.
Right. And education is one domain that may be totally revolutionized with artificial intelligence. This access to good teachers, this is a big, big problem today. Do you suggest to focus more on code optimization techniques and code design or anything else? Okay. So as we said that, hey, focus on code design is one part of it, but I would say focus on architectural design. That's something which is much more vivid. That, hey, how are you going to architect systems? How are you going to solve optimization problems? Of course, very, very important. I would say that in general, how do you optimize something beyond which a pot of gold is hidden? If you try to optimize things, that can be, you can try to optimize your code solution. You can try to optimize a problem in general. That is something which is very, very important, a very good skill to have. I would say that, hey, focus on understanding that, hey, how systems are built, how systems are architected, and focus on developing the problem solving aptitude that, hey, how can I solve a real life problem using the technology that I have? This is the skill which is most important in my opinion. When you say code design, to be honest, I totally appreciate that, hey, writing code the right way is very, very important. It is very, very important if you want to keep your code modular, if you want to keep your code extensible. The first thing which is very, very important of a good piece of software is how well is it written. For example, I will borrow one example from Arvind. So he happens to be the founder of Zeta. He always, if you go and look at all the talks that he gives, he always says one thing, which is that the present banks that we have, if they want to make a new product feature, if they want to add a new product feature, they actually are going to take several years to just add a small feature. The only reason for that is the bad way they have architected their systems or the bad coding principles that they might have used. Because now adding features on top of it is very, very difficult. And this inefficiency has actually created $1 billion market for companies like Zeta, who can come in between there and try to create solutions where banks with their old technology can somehow leverage their solutions and interact with the newly changing world. So yes, code design is important, but I would still say that, hey, architecture design, in my opinion, is much more important than code design. Code design can be automated. You will see as you move along, you will see that, hey, refactoring code will become more and more automated, but designing scalable systems, coming up with architectural solutions is something which is going to be much more important and much harder to automate, in my opinion. Pragya, what do you feel about that, man?
Right, so I totally agree with that. As Tarun said, most of the refactoring things can be automated. However, in refactoring as well, there's a huge spectrum. Right, so things like indentation, things like variable name. Nowadays, if you're using a modern IDE, you almost never care about indentation, right? The ID automatically indents the code. So those are the skills that you're not supposed to learn. The skills that you're supposed to learn in design, in even low level design, are breaking down a problem, right? Taking a problem, collecting the requirements, figuring out how to design the solution for that, right? Learning the design patterns, learning the large scale architecture, or learning the different ways, looking at the different case studies of how different companies have implemented their architectures. Those are the kind of skills that you have to learn. Similarly, skills like understanding data structures and algorithms, right? Because those skills are central to your problem solving. Those skills are the things that are going to be important to you. Learning things like, okay, am I very good at Spring Boot? Am I very good at .NET? Am I very good at JavaScript? Those are the skills that are less relevant to you. And as time moves forwards, these things, these frameworks, these technologies, they are going to be phased out eventually, right? They are going to become irrelevant. The problem solving is going to remain forever.
Absolutely. He says that he has read some articles which says that AI can be very dangerous as well. How companies are taking care of bad aspects of AI so that this awesome evolutionary change due to AI does not end up misusing the technology. So yeah, that's a very, very interesting point.
So first of all, what I would like to say is that yes, I mean, the picture is not all rosy, right? We are not here to paint the utopia over here. Like with any technology, AI gives us a lot of benefits, but it also comes with very significant risks. And since AI has the potential of being one of the most powerful technologies, the risks are also very significant. So let's go back to the invention of AI, right? So perhaps the first artificial intelligence system that was theorized was by Claude Shannon, right? So I'm sure that all of you have heard of that person, the father of information technology. In his bachelor's thesis, he gave information technology, but very few people know that in his master's thesis, he created something called the Shannon's mouse. And that was the first artificially intelligent device, basically, right? And he used to believe that in the near future, basically 100 years or 200 years from now, what we will have robots take over the entire world, right? And Shannon had that opinion. Now, I'm not saying that is going to happen, but a lot of very powerful, a lot of very knowledgeable people also share that opinion. So if you take example of Stephen Hawking, people like Stephen Hawking, people like Elon Musk, people like Bill Gates have warned us about the very real risk of AI taking over the world, right? Now, there's a way to handle this. It's not like there's nothing that we can do about this. This, like most problems, is definitely a solvable thing. However, if you expect just large companies to solve this problem, that is not going to happen. The solution has to come from you. So what I would basically stress over here is, since you are the engineer, since you are the future of the world, it is your responsibility to take these things as a challenge, to upskill yourself in these fields, and to make sure that the AI in the future is safe here. So there's a lot of research that can be done about things like what safe AI is. There's a lot of research that can be done about basically making sure that the AI is not trained on biased data. Right? So you might have heard cases in which Facebook's AI, right, that started tagging black people as animals, right, as orangutans, because it was trained only on the images of white people. It is your responsibility as a machine learning engineer to take care of these things, to understand and come up with solutions for these. Apart from that, there is also a lot of research that can be done in how to best apply AI in the large scale society. So as we understand that, if you look at any particular technology, whenever a new technology comes into the picture, it only increases the distance between the poor and the rich. Right? So this income gap, this disparity between the powerful and the less powerful, this only increases because of a new technology. And that is a very real concern with AI as well. Right? So if you look at billionaires, if you look at large scale companies that are using AI to basically remove out any competition, right? There's also a very real risk of AI being weaponized. So if you see nowadays, there's companies like Boston Dynamics, there's several other companies that are basically trying to automate killing machines. So that is a very, very real risk of AI. And the only way forward, the only way we can tackle those things is, first of all, right, to upskill ourselves in this field, and secondly, to be more vocal, right, to actually bring ourselves into these fields and basically shape the future ourselves.
Right, Pragya, I would just want to add a couple of more points here, which are very, very near term. We can actually see those things happening in a very short duration of time, and maybe we are already seeing those things happening. And this is a very, very interesting conversation. So I will maybe just take 5 minutes to discuss a few things here. So the point that Pragya said that, hey, with new technologies, one unintended consequence of a new technology may be that your bar to entry increases a lot. Let's talk about that a bit. For example, if you want to come up with a new Google Maps today, will you be able to do that easily? The answer is no. It's very, very difficult. The point is that the amount of data that Google has accumulated, it has set a very, very high bar of entry for new solutions to emerge or new competition to emerge. And to be honest, from a very structural point of view, any domain where there is no competition, we are headed in the wrong direction. Similarly, let's talk more about that. For example, Amazon today has so much information about what are the things that we really would want to buy, what are the things that the market wants. Now, if I come up with a new product today, which is very, very interesting, I would want to use Amazon's distribution to be able to reach out to the masses. Now, Amazon can very easily, and it is what it's actually doing, unfortunately, it is very easy for them to copy my idea to create a clone product and to use their distribution to now actually sell that at a much cheaper price now and just gobble me up so that there is no competition. For example, the companies like Swiggy, Zomato, they are valued so much. We have a Zomato IPO coming up in the next few months. Now, Zomato is not only valued because the deliveries that they are making, but a very, very important part there is that the data that they have aggregated. Zomato would know that, hey, if I want to sell curry chawal in Delhi, what's the best price to sell curry chawal in Delhi for? What is the time where people are actually going to order a lot of curry chawals? What happens in different seasons? What happens in different parts of the city? What's happened in different times of the day? Now that data is invaluable, right? And this actually increases the bar to entry. For example, tomorrow if I want to open my own restaurant, or if I don't want to open my restaurant, I already have a restaurant. Now it becomes very difficult for me to compete with a company like Zomato or Swiggy because they can actually use that data, leverage that and come up with a new cloud kitchen tomorrow, which will perform much better than me because they have access to a lot more data. Now what I'm trying to say here is that a very real risk is barrier to entry may increase significantly. The companies that are already powerful may become significantly more powerful, and the others may actually be left out. They do not have the possibility of competing and coming up with ingenious ideas. That is one thing that I fear the most about. And this is not only for AI, this is actually for any new technology that comes up. But this is one thing that I really fear about. Another thing that I would also want to talk about is the information warfare that is happening. So now, guys, if you appreciate, all of us have our own social media presence, right? And the main source of our news happens to be social media today. I hope everybody agrees to that. Nobody now, very few of us actually read newspapers today. Our news actually comes from our social media. Now, try to imagine, try to understand that what we are essentially doing, we are exposing ourselves to the possibility of an information warfare. Now, if in my echo chamber of my social media, I only see the news that somebody else wants me to see, do you understand that you can actually change the way a society thinks? You can change the way a group of people think and maybe hide the things that would have mattered to them and only show them the things that you would want to show them. So this information warfare, you would have heard about companies like Cambridge Analytica. So this is a company which actually helped different political parties throughout the world trying to tailor make their reach, their outreach to potential voters. Now, what they do is they would want to hide all the negative things about a particular candidate that you would not want to show to a particular set of people and only amplify the messages that are very, very heartening for that group of people to see. So if you think about politics, in all honesty, politics or governance is a monkey balancing activity. There is no easy way out. You can't come up with a new scheme which is going to make every single person happy. Now, if you come up with a new bill, you come up with a new law, there is bound to be one segment of people who will be happy about it, and there is bound to be another segment of people who will not be happy about it. Politics is all about monkey balance. Now, if you leverage this information warfare, what you can do is everybody will have, you can put anybody on a spectrum and say that, hey, these are the things that I like about him. These are the things that I don't like about him. Now, what with information warfare you can do, you can only expose the things that somebody would like about you and just make them totally, they would not even know about the possible downsides that you actually come up with. So this is very, very interesting and a very, very important field. The first thing that we should do is to make ourselves cognizant. That is, before making our very strong beliefs about something, just because of a few articles that we read online, first thing that we need to do to fight this is to be cognizant of the fact that, hey, maybe our source of information is biased. Maybe we don't have the full picture in front of us. So it's very important for us to first of all absorb everything and only then try to make opinions. So this is the first thing that we should do. Be cognizant of the possible effects that technology can bring with itself. Okay, difference between a machine learning engineer and a data scientist. How do these two roles differ from each other?
Right. So, there's not a lot of difference between these two roles. And in fact, if you look at most companies, they don't really care about the title. So, there's a lot of gray area in these things, and there's not a clear delineation. However, traditionally, if you look at the data science role, the data science role is more about looking at data and simply making inferences manually from the data. So, for example, imagine that you are part of fintech company, right? You're dealing with a company like DE and what DShaw does is basically take investments from different investors, from large scale investors, and DShaw figures out that, okay, what are the best companies to invest into, right? Best equity companies, best different types of stocks to invest into to give the best return to their investors. Now, if you're an analyst, if you're a data analyst with DShaw, your job is mostly looking at a lot of data about these companies, looking at the past performances of these companies, and coming up with predictions that, okay, this is how the company is going to perform, right? That is the job of a data scientist, looking at data yourself and coming up with inferences. The job of a machine learning engineer is primarily to take this and automate this completely. The job of a machine learning engineer is not to say that, okay, given this data, what are the inferences I can make? The job of the machine learning engineer is to say that, okay, given this data, what algorithm can I apply on it, right? So that the algorithm does the job of the data scientist for. Now, as you can imagine, both these jobs have a lot of overlap between. Like, if you are a good data scientist, it is very likely that you are also a good machine learning engineer. Similarly, if you're a good machine learning engineer, it is very likely that you are good at making those data inferences yourself, right? So there's a lot of overlap, and mostly the companies don't really care about whether you are diving into a data science profile or whether you are diving into a machine learning profile. So what you should focus on is learning the basics of machine learning and data science. You should learn the basics of probability, the basics of this machine learning theory. You should not really focus on what the exact job title is, because those job titles are very meaningless and they are very flexible in the current.
Yeah, just one thing there, Pragya. Of course, there is a lot of overlap between these two job titles, but one thing that I've noticed after looking at multiple job openings and multiple job offerings, I have noticed that companies usually give the title machine learning engineer to folks who are much more heavier on implementation. Their job role will involve a lot more implementation versus people who actually call themselves data scientists are usually folks who would want to just build models and then give those models to somebody else to actually implement. But as Pragya said, if you want to become a good machine learning engineer or a good data scientist, then you will notice that there is a lot of overlap, a lot of skill overlap between the roles. But one thing that I would just want you guys to be wary of, that I have seen a lot of machine learning engineers who do not necessarily have a very good grasp over the fundamentals of machine learning. That is something that you should personally avoid. If you want yourself to call a machine learning engineer, that's great. But make sure that you're not somebody who does not have a very strong grasp over the basics, the basic understanding of data science, the basic understanding of machine learning models. This is something which is necessary if you want to have a good career ahead of yourself. Okay, is there a demand for people who have both the skills? They have data science skills and they are also good software developers. The short answer is, of course, yes. There are lots and lots of companies who would love to hire people who are good software engineers. At the same time, they have a good understanding of data science as well. So if you are somebody who has both these boxes checked, I can assure you, you are going to be in great demand. That is a very, you should actually, if you are a software developer and you are figuring that, hey, maybe what's the next one skill that I should add to my understanding that will maybe help me grow a lot, you can think about data science machine learning. If you understand the principles of data science machine learning, maybe you will, a lot more doors will open up for you. Similarly, if you are somebody who is very good at theoretical data science, you know how machine learning works, you know how different models work, and you are good at understanding models, trying to figure out that, hey, what model to apply in what problem. If you also pick up the skills of implementation, if you also pick up the skills that are important for a software developer, that is, you pick up the skills of architecting systems, then you can increase your value by a lot. You can also increase the kind of impact that you can make by a lot. So that's my short answer. Yes, there is a big demand for people who have both these skills.
Right. And in general, Tarun, I think, pointed this out earlier in the conversation as well. The most important and the most impactful jobs that are there in the world are the jobs that are interdisciplinary, right? The jobs that are at the edge of two different skills, right? So it is always a good idea to be a kind of a T-shaped person, right? You should have a broad perspective. You should try to make sure that even though you have mastery on one skill, you should try to expand your horizon, because the true innovation that happens at those bounds. True innovation happens when you mix two ideas and you come up with a new idea, right? So, yeah.
will ML be the road ahead in tech? Okay, so will machine learning be the road ahead in tech? That yes, in my opinion, machine learning or data science or artificial intelligence will become the dominant player or the dominant theme in the next industrial revolution, the industrial revolution 4.0 that we talked about. So yes, it is going to be a very, very dominant theme, in my opinion. You are going to see lots and lots of new companies and ideas mushrooming, where you are going to leverage data science and build a lot more impactful products. So you think about anything in general. For example, if you think, pick up any domain whatsoever. Pick up, for example, education. Now, you will have a lot of great companies emerging in the domain of edtech, but you can see that in the future, data science, artificial intelligence is going to be a big part of the story in education also. You pick up any other domain. For example, you think about getting people to move from one place to another, right? We already have airplanes which are almost automated. The pilots come into play only for very short durations of time, and also for some of the exceptions that actually can arise. A lot of flying the airplanes is totally automated. Similarly, you are going to see in the future that, hey, a lot of trucking industry, actually interstate traveling over highways, where you have a truck trying to move some goods from one part of the country to another part of the country, you are going to see that this will become automated in no time. There are some very, very interesting organizations, some very, very interesting companies that are trying to automate a big portion of the trucking industry. Of course, there will be a truck driver, but that person will just be there to handle exceptions, and majority of the boring truck driving on highways at a constant speed will be automated. Similarly, if you look at, let's say, self-driving cars is going to be a reality in our cities also, maybe in the next 15, 20 years. So yes, machine learning, data science is going to play a big, big role there as well. To talk about Uber, you talk about Ola. These are big organizations today, right? And you see that, hey, they have utilized tech in a very, very ingenious way and solved a real life problem. But now, what is the major problem that Uber faces today? The major problem that Uber faces today is the driver side of things. If they want to maximize their profits, the first thing that they would want to get away with is drivers, unfortunately. That is what decides in different geographies, different kinds of profits that a company like Uber can make. So now, if you have a scenario where you can use machine learning, you can use data science to actually automate this intra-city driving as well, then these companies can actually become much bigger, and you can have a scenario where tech and data science, being a very important part there, can actually revolutionize industries altogether. If, for example, your driving becomes automated, you have artificial intelligence driving your cars. Now, it's very important for us to understand that this will have a big, big implication on, for example, the insurance industry. Now, if there are no humans driving cars, the probability of you requiring car insurance, most of the accidents actually happen because of human error. If humans are thrown out of the picture, now the probability of you getting into accidents is very less. Why are you going to pay hefty premiums on your cars to insurance companies just to keep your car insured? If the probability of accidents reduce, then this entire industry ceases to exist. Similarly, you can imagine that yes, the next wave of revolution will have data science, artificial intelligence at its very heart, and you are going to see lots and lots of ramifications, and we as humanity moving to a much more optimized version of ourselves. Yeah, that's what I feel.
Cool. So one thing that I would like to point about here is that machine learning is like a spice. Right? With any technology, it spices things up. It adds on new capabilities to what you can already do. So it is not going to be the case that machine learning is going to be everything in the world. Right? It is going to be at the center of everything, but it is not going to be everything. What you have to understand is that the future is going to be, everything in the world is going to involve a bit of machine learning. However, the domains are still going to remain wide, right? So what you should focus on is learning how to apply these skills of machine learning, right? This technology of machine learning in different domains. And that is true with any emerging technology, be it machine learning, be it something like blockchain, be it something like quantum computing. What you have to understand is how these technologies work, and you have to get that understanding so that you can know how to apply these technologies in different problem domains. So the point over here is that machine learning is a theme. It is going to spice up everything. It is not the entirety of the world. Okay.
What are the bare minimum hardware requirements that are required for me to do something meaningful in machine learning?
That's a great question. Now, if you look at most of the sciences, if you look at something like physics, there's an amount of physics that you can learn via the books or via video. So So anything up till class 12th level, you can really do. However, as you move higher, you have this requirement of really amazing machines, right? You require laboratory equipment. You require large scale machines, be those particle accelerators, be those CNC machines, be those a lot of different things. You require a lot of expensive equipment to grow further. Now, traditionally, computer science luckily avoided this problem, because all you need to be a good computer scientist is bare minimum laptop, and you just need your brain to think about things and basically come up with new solutions. However, with the advent of machine learning, especially with the advent of big data, this scenario is changing. For example, if you consider something like OpenAI's GPT-3, it is estimated that training that GPT-3, right, coming up with the architecture is different, but just training that GPT-3 on the data required a person to invest $16 million. So if you don't have $16 million, there is no way you can train GPT-3. So that is true. That is true that because of AI and because of machine learning, you cannot train large models unless you have access to those expensive resources. However, that is only a very small part of machine learning. If you still want to do very core research, right, if you still want to contribute meaningfully to the domain of machine learning, it will remain possible to do that for the next 10 to 20 years. You can still meaningfully contribute to machine learning without having fancy equipment. Don't try to think that, okay, if I want to become a machine learning engineer, then I definitely have to have a RTX 3070, I have to have a top of the line CPU, I have to have a top of the line machine. That is not true. In fact, with companies like Google, right, I'm sure you have heard of tools like Google Colab, right? So a lot of these companies, what they're doing is they're providing free resources for students, for researchers, for startups, free resources in the cloud. So you don't have to have a powerful machine. You can have a very, very basic laptop. You can connect to Google Colab, and Google Colab will provide you the necessary GPUs, the necessary computation power that you need to basically grow in this field and to do important research.
Absolutely, guys. So if you want to start, Google Colab is the answer. That how do you start, right? If you want to train any of your models, go ahead and use Google Colab.
You can learn almost all of the machine learning. You can learn all the systems. You require fancy equipment only when you are dealing with industrial level problems. Only when you are saying that, okay, I have data of millions or billions of users. Now I have to train a model on that. That is the only case when you actually require those large machines, those large clusters. For learning machine learning, you can simply have a basic laptop and use Google Colab completely. Right? That is going to be more than enough.
What are the chances of a bot gonna have emotions and become biased? Okay, so what is the probability of your AI become biased? We have talked a bit about that already, but yeah.
There's a lot of debate around this area. Frankly, from my perspective, I am a firm believer in the fact that everything that humans do, it can be automated, right? So you can totally have a bot which shows emotions. Now, I'm not talking about the big picture. I'm not talking about the philosophical things over here. I'm not talking about whether the bot will have free will or whether the bot will actually be conscious. I don't care about any of those things. What I am saying that the bot will at least be able to mimic human emotion. That is a very real possibility, and that is going to come sooner, right? 20 years down the line, that is going to be a reality. Now, what are you going to do with this bot? Are you going to take a bot like that, and are you going to put that bot in charge of important decisions? Right? That is not likely a scenario, right? Why would you do that? We already have seen that humans make a lot of errors. It is not a very likely scenario that we will have an emotional bot be in charge of important decisions, right? Be it governance or political decisions. Once again, taking your question, having a bot that has emotions is a very real situation, but that is not going to be a big problem for us because you won't have that bot in important decision-making place. Okay?
Right. So, of course, your artificial intelligence can become biased because just by the kind of model you build, your models can always be biased. Pragya gave an example where some machine learning model of Facebook was not identifying people of one particular color as people, which is, of course, your systems can be biased because of the kind of data you feed that to. Emotions, as Pragya rightly pointed out, you can mimic emotions, but to be honest, I personally am not very worried about AI actually being consciousness of its own. It's a very, very big topic. There are very, very strong arguments on both sides, but let's not go there, discuss that right now. But yeah, I would say that, hey, of course, your systems can be biased. You can also mimic emotions to some extent, but that's not the most worrisome aspect here. But yes, how to make sure that your systems are not biased, that is important. And we should take efforts to ensure that the systems do not get biased. Because it's very easy, right? So you can always have a sampling bias and patterns that you show can always be biased and your machine as a result will always end up being biased.
The only way of making sure that does not happen is to take action, right? Don't let your future be dependent on what other people do. Upskill yourself in these areas, be vocal about these things, learn these things, and take action yourself. Shape your own future. That is kind of the summary of this talk, basically.
Makes sense. Make sure that you have a seat on the table. And to get the seat on the table, make sure that you are upskilled enough. So yeah, that's a very nice way to summarize the session. That yes, it's important to maybe try to upskill yourself in these domains, and then so that you can also have a say in what happens with your future. Just one reminder, guys, we are starting with a course on machine learning and data science at Scalar Academy YouTube channel from next week. If you are interested, feel free to join us in that course. It's going to be a totally free course where we are going to take you through the basics and help you become better at machine learning data science. And if you have any questions, feel free to write to us. You can also connect to us on LinkedIn. My name is Tan Malhotra. Pragya was there with me. Thanks a lot, everybody, for joining in. Hope to see you guys again pretty soon. Bye-bye.
Hi everyone, I'm Ramit from Scalar, and today we have a special guest with us who's Puneet. Puneet is a PhD candidate at the University of Maryland, College Park, as well as he is a research intern at Adobe Research in US. Puneet's been a friend of mine from, I can't remember how many years now, we're getting really old, so I don't remember, but it's been a fairly long time, and he was in college with me. So it's been nice to personally see his journey from NSIT in India all the way to Maryland, and now working with Adobe and publishing all these great research papers and all of this. So I wanted to take some time to invite Puneet, given that we've been getting a lot of interest in terms of research and some of the research related initiatives that we've been taking at Scala. So with that, we have Puneet today, who will shed some light on his research exposure, research experiences. We've also got a lot of great questions coming in from the community that we'll also take up towards the end of this talk. And as always, feel free to reach out to me or Puneet on any of the social media channels, and we'll be happy to take up any further questions if you have. So that being said, welcome, Puneet. Thanks for taking the time out. And as we start, I think it'd be good to get a brief introduction of what your journey has been like, an introduction of how you started and where you are today, just so our guests get some context.
Thanks, Ramit. So my journey started from NSIT. I did my bachelor's in computer engineering, graduated in 2018. Then I worked for a year at a proprietary HFT firm, and I was a quant trader there. And after working there for a year, I realized that my passion for AI and ML was more than my day-to-day work. So I shifted gears. I applied to a number of colleges in the US and finally accepted my master's in computer science at University of Maryland, College Park. I completed my master's in 2021 and converted to a full-time PhD student in this fall. So now I'm doing PhD research in AI with specific interests in natural language processing and multimodal computing. And I've been a collaborator with Adobe Research. I also interned with them this summer. And I've also worked with Dataminer, Bloomberg, like as a research collaborator. And very recently also did some research with folks at ShareChat.
That's awesome. I think life goes full circle, right? So we're collaborating, not collaborating together, but at least collaborating within the same company of sorts. So I think it's a great introduction to help people understand. And to kind of summarize, there are a few key decisions that Puneet took, which I think are decisions that all of us, or at least most of us, come to at some point in our lives. So I think let's dive into each of those questions. And to start with, I would say you decided after undergrad, and I saw it personally. I personally saw how you did everything. So you started with an industry role in a high frequency trading firm. And at some point you decided to go a completely different route, right? Like research, I would say, is MLAI research is fairly different from what was being done in the HFT firm. So at what point did you decide that you want to make this change?
So I had this strong interest in AI and machine learning since the third year of my undergrad studies. And by the time I was in fourth year, I knew that at some point I would be going for higher education, especially in the US, because I felt that the opportunities for this specific field are way higher there. So I started working with the professor at IIIT Delhi, Professor Rajiv Ratna Shah. I came under his fold and started working with him sometime in my fourth year. And within a year, I was doing collaborative research with him and a number of other research folks at IIT Delhi. By the time, by the end of 2018, I knew I had the profile. I knew that I can make it to a good master's program. So I applied to these universities, and I got admits from University of Pennsylvania and UMD, and I chose UMD because of a number of reasons. But yeah, this is how I decided why I wanted to do masters.
So broadly, it was mostly getting better opportunities in terms of jobs, etc. Knowing that AI/ML's industry seems to be, doing better. I wouldn't. Some would call it hype. I think it depends on how you think about it. But I think the number of opportunities definitely exceed, what we're at least getting without doing, say, a master's, for example. So I think that makes sense. But to add up to it, I think what you did was you worked for a year and then decided to go for masters. How do you think that decision helped you versus, say, had you gone for masters directly after graduating? So a question that people often have is, should we do masters immediately after undergraduate? Because that way you save more time. You can, save more time and start your career after masters earlier, versus you getting some work experience which could possibly strengthen your profile or even show you what an industry role is like before you go to masters. So what are your thoughts there? What decisions did you take?
Right. So I also had this dilemma. Should I directly apply or should I wait for a few years and then apply? So I guess there are 3, 4 points that come to my mind. One, you get some industry experience, and that actually helps your research as well. So you know exactly what things are already there in the industry and what things are lacking. Second, you also build some financial understanding of what are the opportunities that you can get directly
Right.
in India, and versus when you talk to other people in the US who are already doing masters or have completed masters, you understand the difference and whether you would like a life there or not.
Yeah.
And third, obviously, you buy some time for research. Not everyone is as prepared at the end of their 4th year.
Yeah.
So you always get some time to do.
Right. So diving a little deeper into this aspect of, say, building a research profile in a way. Like in your case, I personally seen you started sometime around your 6th or 7th semester, sometime around that duration. And that obviously gave you a head start in a way. Today, I think there are people of both sorts. There are people who start research much after they, do a job. Kind of like, I think I get approached by people often who say that, is it too late for us to start research? And I think the common answer I tell them is that there's no such time limit. But then there are also people who are starting as early as their 1st or 2nd year, especially with college courses improving or, virtual courses coming up where you can easily take up AI/ML more easily. I think there are more resources now. So what would you say are kind of the essential ingredients that allowed you to take up research? Like what was, like we understand you started with Professor Ajay Vatanshah at IIIT, but what were the prerequisites that you needed? What was the homework that you had to do to get into research early on?
Well, I think there are a few key ingredients that are required before you deep dive into research. One, you need to have strong CS fundamentals. You cannot do any meaningful research without having a good understanding of DSA, operating system, networks, and so on. Second, you need to take a few courses in AI and machine learning, NLP, computer vision, any specialization that you feel you want to explore, because that is where you come across the research questions, the gaps in the literature, and that is how you get started. So these two things are important. I guess end of 4th year or like even 3rd year is the best time to start. You have enough time. You are already done with your internship and job interviewing. You are done with all of those things. You have enough time to spare. Most people like to party or probably spend some time with the family. But if you can spare some time there, that's the sweet spot. That's when you can actually start taking research seriously.
So when we say start taking research seriously, you correctly mentioned, I think we need strong basics, all of those things. But often I think a barrier that people see, which I'm not sure I personally agree with, but I think at times people see a barrier that our college doesn't have a research culture. We don't know enough people who do research. And coming from NSIT, where I would say there was not too much of a research culture either, I think both of us know that personally, but for those who don't, Puneet and me both did research in our final year, published papers, but the college environment that we had was not suited for research. Rather, I would say there's very little awareness about it. So how do you go as someone who wants to do research, has done all the prerequisites, has taken the courses, done all the homework, but still does not have access to a professor or some kind of community where you can do research? What is the homework you do there? Like, when you reached out to professors, what is it that helps you stand out? What should people be doing to get such research opportunities?
So that's true. Not every college has the research opportunities as we find at IITs or triple IITs or other good institutions. So one thing, you obviously need to reach out to these professors. You need to mail them. You need to connect on LinkedIn or through some conferences. And the most important thing is eagerness. You should show willingness that you really want to do research. You can make some good projects on GitHub, probably create some YouTube videos on that, or like just approach through some connect alumni. Uh, these are the few things that most people do. I personally went through some research projects. I showed Professor Shah some of my college projects, and he was impressed by them, and he saw some potential. So I'm glad that he took me under his wings. So that worked out. And I've seen many people do good research even without a good environment. You just need to figure out the right professor, the right mentor, I would say. Even a good PhD student can be a great mentor for you.
No, I agree. In fact, I think something that's good to tell the audience here is, so before me and Puneet started working with Professor Shah, and we first worked with him on separate projects, then we worked together and all of the permutations and combinations. But an interesting fact is that I think one of the earliest papers that we have, I don't know if it's the earliest or one of the earliest, was actually a paper of me, Puneet, and a third author we had, which did not actually have any professor. And I think we made a bunch of mistakes there in terms of where we published the paper and those kind of things. But I think the key point is that we were able to publish the paper, first thing, on our own without any kind of external knowledge. So I think we went from a point where we didn't know anything, like how do you write a paper? How do you start writing a paper? How do you submit a paper? What is the process like? We knew nothing. Yet we did it. We submitted the paper. Oddly, it got accepted, whether you call it luck or whatever it is. Today, I think it's one of the most highly cited papers both of us have. So I think the interesting part here is that if we started with a professor or with some guidance, I'm sure we would have been better off. Agreeably, like we would have had it in a better venue and it would have had more impact and all of those things. But it also goes to show that even if you have a bunch of motivated friends or even classmates who you don't really know well but who want to do research, think like if you have a group project that you've done for a bachelor thesis project. Like I think for Puneet's case, my case, we ended up publishing our bachelor thesis projects which were done in our groups. So these are easy ways for people who don't have a research community to just start. Like I think something is better than nothing. And if you start, you will reach a point where you understand how to go from step A to B. But you need to be there where you start publishing or start doing some kind of writing stuff. So as a follow-up to that, I think both of us have made early mistakes in terms of research that we've done. What are some good pointers that you would give to people who are just starting out with research? Like they have a group and everything, but what are some important key quick takeaways that they can have before they submit their first paper or before they try to write their first paper?
So I guess it's an iterative process. There's a lot of hit and trial involved, and you can never get it right. So understanding this fact itself is a major boost for many people, because most people just keep wondering what they should do and end up doing nothing. So one, understand that you're going to make mistakes, you're going to face rejection. Rejections is a part of life. It's a part of life for every researcher, and I would say everyone in the industry, in the research community, does a bunch of mistakes they're really embarrassed about. They never talk about it, but I think everyone should talk about that. Second, read more. The more you read, the better you'll have ideas, the better you'll write. So this is important. Read papers, even if you don't understand them, just read the abstract, read the methodology, ask questions, mail the authors, like try to discuss them in a group. So this is pretty helpful. I guess almost every good university has some research circles.
Yeah.
So try and attend those research circles. Try and get some good ideas. Come up with ideas. People will shut down your idea, and you'll feel rejected at that point. That's okay. Just keep trying, and eventually you'll come up with a good idea. Start implementing it. You'll make mistakes, and you'll probably falter along the way, but eventually you'll reach a point where you think that you have done something major, the contribution is good enough. At that point you can approach a mentor, a professor, who can evaluate your work, look at the key contributions, and then propose a good venue. Aim high, like be as ambitious as possible. And when you're ambitious, you obviously tend to fail again. You'll get rejected by good conferences.
Yeah.
That's okay. Your first few papers can be in not so good conferences, but keep improving. It's an iterative process. The
Yeah.
next project should be better than the first.
Yeah.
So I guess
Agreed.
these are the important points.
Agreed. So a little more in terms of motivation. So I think what you were doing in terms, and this goes for a lot of people, like what you were doing in terms of a job. I know personally that you were doing well because it was one of the highest paying companies that came to our campus. So from that perspective, what makes you go from doing a job in the industry that is going well for you already to go for masters? Like what are the key motivations that people would want to consider doing such things? Like we see so many people, but to those who are still wondering whether they should stick to their job they have, is the investment in a master's required? Is it worth it? All of those questions. So kind of trying to understand what your journey was there. Why did you essentially choose to do masters, especially because you were already in a good place?
So I guess everyone has their own reasons. My personal reason was because I wanted to deep dive into AI machine learning space. I wanted to explore both industrial as well as academic NLP and computer vision. And I eventually wanted to get into an industrial role, such as machine learning scientist or a research scientist.
Yeah.
And a master's or a PhD is kind of a necessary for such roles, at least in the United States.
Yeah.
In India, I still feel that if you have done a good bachelor's, like you have done some really strong work during your bachelor's, the bar is still there. But in the US, like with all the different PhD and master's program, it kind of becomes necessary, and it actually helps because you go through that journey where you learn so much. Like my entire master's and the part of PhD has been full of learnings, and I feel that everything will be super helpful when I transition into industry.
Yeah.
So this was my motivation, getting into an industrial research role, and which is why I chose University of Maryland, College Park, over other extremely reputed universities, because UMD offered the kind of courses and the kind of research opportunities that I was looking forward to.
Yeah. I think an interesting thing that people don't know is that Puneet also got scholarships for masters, and in most cases, PhDs in US are anyway funded. It's not a role that requires more investment from people's side. So often I've seen that people would kind of, at least in their mind, inflate what amount of investment it would be to get into a master's or a PhD. But I think eventually, even if it's not always about a monetary aspect, but even if you think from a monetary aspect, I think the returns are well worth it, especially when you start thinking of how you'll earn in the US and what kind of returns you get from that. I think eventually those things balance out. And I think it's good to have Puneet here, who brings that interesting exposure where, although he's doing a master's and a PhD, but eventually would like to do something more industry oriented, as he's doing with his collaborations with that he's done with Bloomberg, now with Adobe and with ShareChat. So he's always had that research exposure within the industry. Now, an important point here is that when you are doing or looking for this industry kind of work in, after your master's or your PhD, what are the benefits that you think you got by doing this master's or PhD, which you would have not got otherwise? Let's say if you had done, say, I think obviously one of the biggest things is that you get to live in the US if you want to, and that comes with its own pros and cons. But other than that, in terms of absolute job opportunities, like even if you had to come back to India, for example, what things do you think you've got an edge over with such a program?
Okay. So I guess the number one thing is that before my master's, I was more of an engineer. My work involved designing applications and solving problems which do have a deterministic solution.
Yeah.
Uh, as a researcher, as an applied AI researcher, I feel that I'm working on things that do not have a deterministic answer. Let's say the kind of projects that I have done, the kind of research publications that I have looked at, I won't say they are solved problems now. There's much work that needs to be done. But the kind of roles that I will now be looking into will require me to come from a mindset where I'm not just thinking of solving the problem for a specific company or just doing my job, but contributing to the larger research community as a whole.
Yeah.
Let me give you an example. So, very recently, I did a project with Adobe that involved working on layouts and documents. So, the problem was not deterministic. In fact, it's a hard problem. It's still not solved. We have made much progress in the space, but there's still much to do. But whatever work that has been done has actually improved the state of the art by some X
Yeah.
percentage. So it's an iterative journey where you keep improving,
Yeah.
and the companies want to hire such people that can think creative solutions for solving these hard problems.
Yeah.
So this is the context. If you want to solve hard problems and apply creative solutions to it,
Yeah.
a PhD offers you the best platform to start doing this early on in your career.
Yeah.
And once you keep doing this for, let's say, 2 to 3 years, with different collaborations on different projects in different domains, you get into that mindset so that when you transition into the industry, you already know how to approach these hard problems.
Yeah. No, completely agreed. I think another interesting thing that people should see, that what one gets out of a master's or a PhD, is that you do a lot of industrial internships along your way. I think at this point, within 2 years, you work with at least 4 or 5 companies easily, maybe more through your collaborations. And that allows you a lot of different industry exposure. And it sets you up for some really niche roles that someone without a master's or a PhD would not get. Me personally, having not done a master's, for example, I've often had conversation in conferences where people would say, oh, you don't have a master's or a PhD, so you would not be a good fit for some of these roles. So when you think of something like, when you see roles like Facebook AI research, you see roles like Google research, Adobe research, the big thing to keep in mind is that yes, these roles are slightly more prestigious, they're slightly more selective, they do come with better pay packages, with better benefits, attending conferences, networking, all of that. And the pathway to that is showing that you can do applied research, which comes with masters and a PhD kind of degree. That definitely comes. So pretty much agreed over there. Taking one step into understanding how one gets into such masters or PhD program, but even before that, I think an important thing to understand for people is, so we spoke a lot about papers, right? And people who are more research oriented might know what these papers are. But to those who don't have that much of an idea, those who are starting research, who want to get into these type of roles, I think it's important to also shed some light into what your profile had when you were in NSIT before your papers, and what the papers added to your profile. Like personally, I think from a third person's point of view, I feel if you, and maybe I could be wrong here, I was not on the application committee, obviously, but I feel that what separates you or me or anyone else from anyone else in NSIT, say if you leave out the grades or some of the internships, etc., was the paper. So I'm just trying to understand that what kind of role do you think having such research publications over, say, research projects, etc., has helped in terms of your entire journey, like getting a master's, PhD, getting better internships, better jobs? What roles do papers have in these?
Okay, so let me talk about the admission process, because this is something that many people are interested in.
Yeah.
So we need to understand how US universities work. Let's talk about the master's level.
Yeah.
There are three types of universities, and this is just my opinion. I might be wrong.
Yeah.
But I've seen three types of master's program. One are completely research focused.
Yeah.
Second, they are more course focused. They just want you to do good courses, get good grades, and transition into the industry.
Yeah.
Third are a hybrid mix. They want both, best of both worlds. So I'll talk about the first category because UMD's master's program is extensively research focused.
Yeah.
So most of the courses have a research component. You have to work on an open-ended problem, write some white papers, technical reports, submit it as part of evaluation, and all of those things.
Yeah.
So such university programs are selectively few. They are pretty selective in the nature because they are looking for people who can do research, and they have plans to continue doing research even after graduating.
Yeah.
So they're looking for people who either want to get into a PhD after the masters or want to do more applied research, let's say a research engineer role. Or when you talk about AI machine learning, this can be more of an ML engineer role.
Yeah.
So they're looking for such kind of people. And because they are so selective and they know the kind of journey that these students will have, they also try to fund as many students as possible. So UMD was generous enough to give me a full ride through RA and TA during my master's program and obviously through the PhD. So this actually makes your path easy. You just need to focus on the research side of things. You just need to focus on the next set of things that you want to do. You either get into a research role in industry or a PhD, apply for PhD programs. You don't have that loan burden on you. How to get into such programs? So obviously, when they are talking about research, they want to see what you have done before.
Yeah.
So have you worked with professors? Have you published good A-star papers? A-star means the top tier papers. Have you done some industrial research internships that makes you qualified for this program? So all of these things do matter. When I talk about my resume and my profile in general, so coming from NSIT, I had moderate grades, and I would say I had 1 year of industry experience.
Yeah.
But what set me apart was the research experience that I had at IIIT Delhi.
Yeah.
And also the papers. I had one faculty paper and a couple of workshop papers in ACL, EMNLP, and other top tier conferences. So that set me apart from the applicant pool.
Yeah.
And once you have these papers, it's very easy to get LORs from the people who you have worked with.
Yeah.
And you can also write the entire story of how you transitioned into research, how you published those papers, what things you worked on in your SOP. So this SOP acts as a proof of everything that you have done. The LORs back that proof through someone who has mentored you very closely. So you don't actually need to go and have someone write a LOR for you. Or a lot of students do this. They also write their own letters, just trying to praise themselves. But I guess these are very shallow letters. They don't count that much in the process. So, but if someone accredited who is a professor or has done extensive research, actually vouches for you, and you show that you have done some good work, that sets you for the program. That makes sure that you will have a good chance of getting admitted into such a selective program.
I think I'd add on to that I wouldn't necessarily say that research publications are necessary for getting into a master's or a PhD program, or that they're necessary to get into an AI related industry role. Nor would I say that necessarily having them would definitely increase your chances. But I would say that there's a very strong correlation between the two things. It's basically a demonstration or a proof that the project or the work that you've done is something that helps the community, fast forwards AI research, shows that you develop big and useful practical skills. So it stays forever. I think one of the reasons why I did research, even though I wasn't sure if I wanted to do a master's or a PhD, etc., was that I think it's contributions that help you learn and grow. It adds a different perspective to your world. But most importantly, these are things that, unlike a job, for example, they stay with you forever. Like once a paper is published, it's there forever. It shows that this is the work you've done. So from that perspective, I feel these are things that have drastically helped separate many people, including Puneet when he went ahead for his master's and PhD applications. Even when you go for industry-oriented roles now, in fact, when I've been talking to people at conferences, etc., one of the way people objectively try to evaluate what is the level of your research, they see what papers do you have. The common questions when you've graduated after a PhD is what papers do you have. So I think an important part with any research oriented roles, even like within machine learning, AI, especially because of how new and cutting edge the field is, if you're not contributing new problems and the only thing you need know how to do within ML and AI is taking existing algorithms and plugging them into your code, sure, that's great. That fits better as a ML engineer, etc. But you'll truly start adding value when you're able to modify that to newer problems and create newer AI solutions for all of these. And research is kind of the stepping stone for that. So I think having set enough context, and since you've made this decision yourself, what do you think would be the right people, or who do you think would be the people who should consider doing research, even if they're not people who want to necessarily do research forever, temporarily getting into research? Like, who should these people be? How do you decide if I'm the right person to take research up?
I guess the community is inclusive and it doesn't differentiate if you come from academia or you're a student or you are a career professional. I guess everyone can contribute to research, and in fact, this should be how it
Yeah.
right now. Most of like 90% plus people are the ones who either want to get into a
Yeah.
master's PhD program or who are currently in the program. But this is how it should be. Uh, we are very welcoming in that sense that we want newer perspectives.
Yeah.
So even people who have worked in industry for a number of years and now want to make like probably change fields or want to get into more cutting edge technologies like AI, ML, quantum computing, or so, they should come forward. They should start collaborating. Probably you can collaborate with other industrial labs or some academicians or some research groups at the universities. And I guess the community is open for everyone.
Yeah. What kind of career prospects do you think would come up? Like, I think often people think that after a PhD, at least, for example, or if you get like, too much into research, people often think that one of the things is you become a professor or an academician, which is nice for some people. But I think that there are a few other benefits that come to it, especially from your perspective, where you eventually would look at something more industry oriented. How do you think, or what kind of career progression do you think you would get differently now that you have some research exposure? What do you think is different, and what do you think would be a better or a more aligned career path for you now? What do you think now separates you that you've done this master's and PhD?
So I think it's not just about masters or PhD. Or I would say anyone who has spent considerable amount of time doing research should get opportunities to contribute at a scientist level. I think the whole process of research trains you to think about new problems, to solve hard problems in a creative manner, and come up with some non-trivial solutions. So this is what it is. Like in the industry right now, research scientist roles, applied scientist roles are hot in demand. And I think having good research experience will make you eligible for such roles.
Yeah, agreed. I think all in all, I would say this, that if we talk more objectively, I've seen that personally, I could be wrong here, but I've personally seen that research, it's more of a demand supply kind of thing, where research oriented roles, even in ML, AI, subsidiaries of it, perhaps even things like Web3 soon, crypto, etc., all of these things, there's a lot of demand for these because these are what are going to shape the future and already are to an extent. But the supply of people who are, I would say, have expertise in these is lower, perhaps because they're more specialized roles. You need to do a little more work than just your undergraduate college degree, for example. In fact, you need to do a lot of extra work if you want to specialize in anything, and that holds true even more for ML and AI. So eventually what that leads to is, because there's more demand and less supply, it naturally means that whether you're looking at industry oriented roles or other oriented roles like focused on academics, whatever, it's simply that often the benefits that you get, whether it goes from compensation or generally the other advantages you can get, are more significant simply because it ends up being a demand supply kind of game. How that pans out in the future, we'll see. But for now, I guess that's where it stands. And it's going good for Puneet. So I think for now, that's good. So talking a little bit about your exposure in terms of the work that you are now doing as, now that you've got into research, how do you think that differs from the kind of research that you were able to do before? So, both of us are people who've done research during our undergraduate also. But I think the research you did back then, and rather the style in which you did it, like the collaborators you had, etc., how does that differ from what you have today? Like, what doors would you say have opened for you now that you've done all this research?
I think the main difference that came, especially in my style of research, when I was working at IIIT Delhi versus now that I'm a full-time PhD student, I have this liberty of thinking about bigger questions, more impactful problems. Like some of the problems that I'm currently working on, these are in document space, natural language processing, computer vision, are more fundamental questions. And I guess contributing to such problems would help move the field further. Earlier, I was working more on application focused problems that were trying to solve one specific small, narrow application in some subfield. So this has certainly changed, and it has opened doors for some better collaborations. A lot of people are not specifically tied to an application, but want to work more on a fundamental problem. Let's say you're working on natural language processing, you look at BERT and you see that BERT has its own challenges. BERT doesn't scale well for large documents. How do you solve that problem? So what are the different methods that you can apply? So now this is considerably different from solving a problem, say hate speech detection on a data set sourced from the internet. That's more trivial. It can be solved using some of the existing technologies by combining a bunch of different things. But this is a more fundamental problem. Tackling this problem means almost every company, every research organization is now more interested in your work. So I guess this comes naturally as you keep doing research, you mature in a way, and you realize that there are better questions that need to be answered. There are better problems that need to be tackled.
Yeah, no, completely agreed. I think one of the biggest benefits is having exposure to, I'd say, more general problem statements that can make a bigger impact. Like, I think when people start research, we all start from an application perspective. Like, you start with the data set and you try to solve that problem, which is a good way to start. But when you want to start creating actual value, you need to solve bigger, more general problems, which at times come with greater exposure, with better connections. And I feel like doing some research on your own is a good way to start with that. So I think it's been really helpful understanding a lot of your journey, understanding a lot of those decisions, which have been really helpful. Now, we've got a huge number of questions that came in from Twitter and LinkedIn as well. So I'd like to start by taking some of those and getting what your opinion is on them. So the first question is, how do you choose a research topic and publish a research paper for the first time? I think it's a good question because this is where most of the people today stand. So
right. So I guess your first research project should be entirely based on interest. What topic actually interests you and you solving that? So I guess this is how I started when I looked at the internet in general, different social media platforms like Facebook, Twitter, and I found that there was high volume of hate speech, and I wanted to solve that. So I started studying what tools and technologies I can use to solve this problem. I got introduced to different aspects of natural language processing and social media analytics. And this is how I started my research journey. And then solving next problem and then trying to solve other sub problems, you tend to form a research topic of your own, and then you can keep contributing. So this kind of creates a niche, and then you can either keep exploring the same niche, or you can then digress to some other topic in the related domain.
Agreed. I think one of the important things to keep in mind, which people don't look at, is you need to focus on what your interests are. Like, eventually agreed, you're doing research because you want papers and that helps your master's application or it helps you get better jobs, better salary, etc. But if you want it to be sustainable, you need to do something that interests you. That I think holds true for anything in life, but even more so with research. Start with a problem statement that you have some interest in. Most likely it'll be an application, and I'll give you some broad applications of it. You like something like Pokemon, for example, like me, you'll find research papers that do things about simulators on, beating or like building bots for Pokemon games, for example. So there's research to do in a lot of different areas. It doesn't have to be very mathematical, geeky. At times, you don't need any prerequisites. You can start from anywhere, but start with what interests you. I think that's a good way of thinking about it. Now, the next thing is a lot of times bachelor's degree or things that people are doing in their undergrads are very fixed. I think that's changing now, but at least back when we were looking at it, things had a very fixed curriculum. In such a case, how do you, or what is a good way in which you can choose a research topic which will be in sync with your bachelor's degree?
Okay, so this depends case to case, but the general idea is that you should approach your professors or your thesis advisor, because most of the times we don't realize these professors, they have been doing research for a very long time and they know what are the good open problems that you can contribute to. So feel free to reach out to your thesis advisor or probably some senior in your college and try to get some ideas. And yeah, that's a good way to start. Like, this is what I did. I started with a research project that interested me. I based my bachelor's thesis project on the same, and then went for a publication. So this basically helped me get a good bachelor's thesis as well as get a good publication.
Right. So following up then, this is, I think it's perhaps, a more common question that I've seen often is how difficult is it for a non-core student, for example, like a, chemical engineer, for example, to get into something like ML and AI research? Because often we've seen ML AI research at times at least has a prerequisite of computer science. And often those students tend to get a preference during master's applications or even industry oriented roles. I think just to just give an answer before Puneet even answers, I think papers are a great way which show you that value. But over to Puneet, like what can people do from non-core branches to compete with people in CS related branches for MLAI roles or master's applications, etc.?
I would say don't see your degree as a handicap. See it as an advantage that you have done something that none other applicant knows about. So if you have a degree in chemistry, why don't you start from there? Why don't you look at applications of machine learning and AI in chemistry? There have been a number of papers on identifying and classifying different chemical compounds based on some analysis. So you can start from there. You can look at problems that involve machine learning and AI in your specific domain, and then try to get some papers out, try to publish that work. And that's a very good start. And that shows that coming from a non-traditional background, you still made it work. You still have the fire in you to keep going and learning new and better things.
Yeah, I think that's a very wise thing to say. In fact, it adds perspective to myself as well, because it's kind of a broader message here is that you are kind of using what's different or what you would think as a handicap about you as a strength, perhaps. Like when you start doing research, you'll realize that there are certain problem statements that everyone has done. I'll give you an example, like if you've done the Andrew NG course, for example, which most people do, or if you've done like some Coursera course on Boston house price prediction or classifying handwritten digits. At this point, every second person has some random project like that in their resume. But if you come from a chemistry background, you can use that to show a very different side. In fact, something about research that's good is it's very interdisciplinary. So often we work with people not just in CS, but we work with people who work in other domains. And that again opens up a lot of different opportunities for you, because you can start working with, like Puneet said, chemical engineers. In fact, when we do work around mental health, we work with people who, psychologists, doctors, all of these things. You get a lot of different exposure, and research allows that, because together we're all working on an open scientific problem. So definitely keep Puneet's points in mind about that. The next question around...
Right. And to add to that...
Yeah, go on.
Just wanted to add one more point. When I started Professor Rajiv Shah at IIIT Delhi, my first project involved working on medical images, and I had zero idea how these medical images are analyzed. Doctor who was a practitioner from the last 20 years, and he had a ton of domain knowledge about medicine, about histopathology, and different things.
Yeah.
And that added certain zing to the project. That I came from a machine learning background. The collaborators came from a medicine background, and we tried to complement each other's strengths. And this actually led to a very solid paper.
Yeah.
Because it tried to solve different problems in both the domains.
Yeah.
So this can always be advantageous. If you are coming from a non-traditional background, do not think yourself a second to anybody else.
Yeah.
So just keep
Yeah,
focusing
I think
on
that
your
I think
strengths
that's a great
and try to collaborate with people.
Yeah. I know. I think that's a great example. In fact, if we think about it, that is so. Before Puneet applied for his master's program, that paper, in fact, the biomedical one, I think was the biggest contributor to that. So yeah, I think that's a great example of it. And following up, another question that we have from Twitter is along similar lines, and perhaps I think we've answered part of it, but we'll take it up properly again because this is, I think, the question that everyone asks. So, do we need to have a paper published to be considered, especially for a PhD position? And can you explain more briefly? Even I think one thing we can dive into is when you're thinking masters versus PhD, what are certain other things that your profile needs to have, and perhaps how important are these papers for masters, PhD, industry AI related roles and such?
Right. So having papers or not is a very controversial question. Different people have different answers.
Yeah.
I'll try to answer according to my experience. So I would say that if you don't have a very strong research profile, you don't have really strong papers, you can still try for a good master's program. And during the master's program, you can work with some professors, try to get a few papers under your belt, and then apply to the PhD program, probably in the same university or some different university. That's one way to go. If you already have good papers and you feel that you strongly want to do a PhD, then you should directly apply to a PhD program. That saves time, that saves effort, and keeps things very direct. Having a paper is always advantageous, even if some people say that it's not required. Most applicants come with a few good publications in their profile. So try to keep this thing in mind while you're applying. And because this is the application season, I guess a lot of people would be anxious whether they'll get into their dream university or not. It's always subjective, but at the same time, it's good to have.
Yeah. No, agreed. I think those are good points around it. And again, I'll just reiterate what both of us said earlier. It's an important thing to keep in mind that I don't think papers are mandatory for PhDs or masters, and nor does having a paper or bunch of papers give you a guarantee that you will get into it. But there's a very strong correlation between them. In fact, a good way to understand how this correlation exists is go see the university you're interested in. Take Stanford, for example. Now take a look at all the PhD students there, master students there, and see what their profile has. And you'll get an understanding of what differentiated them. Try to speak to them and you'll see what they would say differentiated their profile. Like now that we have Puneet here, for example, if I asked him, in fact, I will ask him now, what do you think is the one thing that played the most important role in your master's PhD application process? If you had to narrow it to one thing.
Complete answer to this because I never interacted with the university.
Your own opinion of it.
Me, but but my opinion of it is that the publications did play a very important role.
Yeah.
So that was critical. Without that, I don't know if I would have gotten to UMT or UPenn for that matter.
Yeah. No, agreed. I think those are all good points that have been raised here. Now, a few more questions. I think we have a lot, but we'll try to take some that are more generic and relevant for people. Okay, so this is, I think, a question that, again, we briefly touched upon, but it says, there's someone who I think has completed their master's degree in 2013, so it's been about 8 years now, and they're interested in considering something like getting into research now, which is again a common question that people have, that is it too late for us to start research or get into MLAI, etc.? Because when they were starting, there was a different paradigm. There weren't so many resources available.
Right.
So what would your suggestion be at this point? What do you think people who are already doing jobs or people who already have a good amount of experience, how can they get started? Especially because they don't have enough time. They don't have the same opportunities at times. In fact, some of the people who graduated much earlier, in fact, someone I spoke to told me that they have a newborn and it's difficult for them to manage all of these different things. So what would your suggestion be to people who already have a lot of experience, but now want to get started?
Okay, so there are two parts of this question. One, getting started into machine learning AI in general. Second, getting started into research.
Yeah.
If you want to get into MLAI, there are a number of courses that you can do to upskill.
Yeah.
You can probably, I guess, Scalar is coming up with some good courses in data science and machine learning space. So there's something to look forward to. If you want to get started into research, I guess getting your hands dirty is the only way possible.
Yeah.
You will have to take a side project. Let's say you don't want to publish, but even if you take a good side project, or probably just take a publication and get the code and try and implement it at your end, even that can be a good start. So that can teach you the basics of dealing with problems, trying to get your hands dirty, and then you can figure out if you really want to do this full time or do you want to keep it as a side hobby.
Yeah. No, I think that's an important point. The most important thing is that there's no shortcut, unfortunately. But it also doesn't mean that if you haven't started yet, you can't start now. The good thing about research is, like we said, when we were in our last year of undergrad, you don't need anything special to get started. You just need to have some motivation. You need to find like the correct things to do, because MLAI research is a very, very, very broad topic. There are way too many things happening, reinforcement learning. People at times can start with things that are far off. NLP, computer vision. I often get questions like, what should we start with? Should we start with NLP or computer vision? And the correct answer to this is you can't fit the same answer to everyone, but it's important for you to start. And, like Puneet mentioned, there are a bunch of free courses, paid courses, and I won't get into the difference between what would make a paid course better than a free course, etc. But I just feel having some kind of guidance along the way is helpful, especially if you're not a student. You miss out on things like having college communities, for example. So when I was in, what differentiates me today, like now that I'm doing a full-time job, or back when I was doing a full-time job in, say, a tower, for example, or when Puneet was working in ST, the HFT that he was working with, we worked with people who did not have an MLAI background experience, or perhaps even the time to do it. So at this point, we couldn't just go and randomly find people who wanted to work on research projects with us. Whereas during college, me and Puneet were just talking one day randomly, and we decided, why not start doing it together? So as you become more experienced, it becomes important to find some community of people who can help you do this. So, try looking for communities, courses, and no time is too late to kind of upskill yourself in that way. Okay. Just looking at one or two final questions, which aren't so much about research journeys, but a few important questions on ML and AI in general. And this perhaps would be a better, Puneet is a great person to answer these. So fairly long question that I'll try to trim down a little bit. But I think one of the questions is, why is research so hyped up, and why does funding things like deep learning models for generating captions for images get so easily funded? Like, I think we all know that research has a tremendous amount of funding behind it. In fact, all the industrial roles pay a lot more, etc. So then why does this tend to happen? Like, why are these being perhaps paid more attention when there are in fact more serious issues, perhaps? So just I think the broad summary of the question is, why is there so much funding money behind it? Why are these things perhaps so hyped up? Like, what's the entire hype about these things?
I guess it all starts from money. Like, if you have the right set of funding for a project, things are easier to push forward.
Yeah.
And a lot of companies want to solve problems that can generate profits for them.
Yeah.
And when they see that there's an easy path to profitability through those projects, there's more cash flow.
Yeah.
At the same time, there are a lot of NGOs and other government organizations that are now looking at applying AI for, let's say, climate change, reducing pollution, and such societal problems. I guess there are a few good organizations within India as well,
Yeah.
which are now using AI for solving such problems. I know Google Research does a lot of AI for social good work.
Yeah.
Wadhwani AI is another similar organization. So people have started looking at these things as well. Obviously, they require more and more people to get interested in the space.
Yeah.
And if someone new is starting, should be looking at AI for good, because this is one space that has a dearth of people, but no dearth of problems.
Yeah. No, I think that's an important thing, that I think whether it's hype or not is difficult to say from an individual person's perspective. I think it differs from every person's perspective. Like some would say crypto is hype, some would say crypto has its own benefits. So I think that's the answer there is more of to each their own. But I would say this, that you should not get into it because of the hype. You should only get into it if it actually interests you. And I would say that's the takeaway here, that AI has a lot of shortcomings in terms of ethics, privacy. We won't get into any of that today. I think that's a much bigger discussion for more qualified people than myself to talk about. But I feel it has its pros and cons, just like everything else. But the important thing is that it does have applications that are making good progress today and will shape up the future. Perhaps a lot of the AI research that happens today is something you don't see for the next 1 year, for example. It takes a while for these things to go from research to a real world application. Like when you look at industry, when you look at software, for example, you often see that the code you do, it goes live in a few weeks, months, at times even in a few days, and you can see real impact. With research, that impact is going to take longer to come there, and it might take several different iterations, hundreds of people working on the same problem for years to make any impactful, meaningful results. And at times the whole thing might lead to failures, but ultimately there's some learning that comes out of it. And I would say a lot of the things today have changed in terms of how AI works. So I'll start from small examples, like things that one would say might not be the most meaningful, but still, if you look at social media, for example, most of social media moderation, like hate speech detection, etc., all of these things are now much better because of how AI is able to handle them. Feed generation, pricing algorithms, all of these different things work with AI as a backbone. It is definitely possible to have those applications without AI, but there's so much that AI makes possible. Even if you go to medical applications like the work Puneet did earlier, where you can use AI to look at X-ray scans, different types of MRIs, etc. AI definitely helps. Whether that money could have been put to better use or not, perhaps is again a question out of scope for our discussion here. But I think it's a great question, which involves some interesting thought-provoking points. But I'd say this, that despite those opinions, AI is here to stay for sure. So if it interests you and you think the opportunities are great, you should perhaps look into getting into that. So yeah, I think that's a summary of most of what we had. There are still a bunch of questions, but I won't get into them. I think we've hit around a 1 hour mark, which is quite a bit. Puneet's a busy person who's taken out a lot of his time from his busy PhD meetings. So we'll leave him now. But that being said, thanks a ton, Puneet, for being here. We've hopefully answered a huge number of questions and clarified a lot for people that are interested in these things. But as always, if you're interested, feel free to reach out to us via Scalar. Any questions that you have, reach out to us via social media, LinkedIn, Twitter, whatever it is. Feel free to reach out. We'll be happy to talk more about these things. And hopefully, Puneet, keep doing the great work with research. And hopefully someday we might have you, we both of us might be on another Scalar session soon.
Thank you, Ramit. It was great having this conversation with you.
Yeah.
And I hope everyone can learn something from this AMA.
Yeah.
So
okay.
Please feel free to reach out through mail or any of the social media links.
Okay, awesome. Thank you, everybody. Bye-bye.